All right. Good morning to the respected professor, associate professor, lecturers, teachers, ladies and gentlemen. Right, my name is Eng Fong Chiu. You may call me Fong. Lecturers, teachers, ladies and gentlemen. Right, my name is Eng Fong Chiu. And I will be the MC for today. Right? Now, on behalf of Sept, I would like to extend a very warm welcome to everyone to the Bengkel Perkongsian Amalan Terbaik Guru STEM dalam talian tahun 2020. We appreciate you share your precious time to join us today. To begin this program, we are pleased to invite our President of Sept, Associate Professor Dr. Azida, to have her opening remark. So, Dr. Azida, please.
Thank you, Miss Fong. Thank you, Miss Fong. Thank you, everybody. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera semua. Terima kasih. Thank you very much for attending this webinar. Okay, webinar on Bengkel Amalan Terbaik Guru STEM 2020. Okay, we the organizer from Sept, ya. Kami adalah dari Persatuan Pendidik Sains dan Matematik Pulau Pinang, alright, Association for Science and Mathematics Educators Penang, dan mengalu-alukan kedatangan anda semua, okay, kehadiran anda semua kepada webinar yang julung-julung kali kami adakan untuk semua guru-guru, ya, semua guru-guru di Malaysia sebenarnya, walaupun ianya adalah satu program untuk guru-guru Pulau Pinang, tetapi kami buka juga untuk guru di Malaysia dan juga guru-guru dari Indonesia. Okay, jadi kita ada peserta antarabangsa hari ini yang kami sangat alu-alukan kehadiran anda semua. Okay, so a little bit on Sept. Saya akan menggunakan dua bahasa, ya. Alright. A little bit on Sept. Sept is satu persatuan, ya, satu persatuan profesional ataupun juga kami juga adalah NGO yang cuba mengenengahkan. We would like to highlight the mathematics and science educators, as well as sekarang kita integrasi juga guru-guru teknologi dalam persatuan ini, alright, untuk membantu, okay, ataupun membantu dan sama-sama berkongsi ilmu dalam mathematics dan sains. Jadi salah satu agenda kami pada tahun ini adalah mengadakan webinar ini. Alhamdulillah hari ini berjaya kami adakan. Diharap, okay, didoakan semoga hari ini berjalan lancar dan semuanya mendapat manfaat dari perkongsian ini. So untuk guru-guru, selamat datang. Okay, diharap perkongsian ini dapat membantu anda semua dan alhamdulillah ianya adalah percuma, gratis kepada semua. Okay, dan anda boleh juga mendapat mata LDP, ya. Jadi nanti kita punya pengacara Miss Fong akan bagi reminder bila anda perlu letak feedback untuk e-certificate dan sebagainya. Jadi kami berharap anda semua akan dapat manfaat, alright. Anda akan semua we get benefits from this particular activity. So saya tak nak berbicara panjang sebab mungkin anda semua ternanti-nanti, okay, perkongsian daripada 6 orang panel guru-guru dan pensyarah yang akan berkongsi pada hari ini. So I hope that you will enjoy and benefits from this particular sharing. Okay, jadi itu saja. Terima kasih banyak-banyak dan sekiranya anda ada soalan, sila letak di komen YouTube channel ataupun Facebook dan kami akan cuba mengenengahkan komen anda, alright, di skrin ya, sebagaimana yang tertera sekarang. Miss Fong Yuen Yi, good morning. Okay, so anda semua akan ke udara bersama-sama dengan kami dalam YouTube channel. Okay, terima kasih. Back to you, Fong.
Okay, thank you Associate Professor Dr. Azida for the wonderful opening remarks. Now, ladies and gentlemen, our workshop today consists of two sessions. The session 1 is from 9 a.m. until 11, and session 2 is from 11 until 1. And we have 3 speakers in session 1 and 3 speakers on the session 2. So in case you have any feedback or any questions, right, you can drop your comment on YouTube or Facebook Live, or you can email to the speaker. Okay, so the email of the speaker is this. Okay, I'm sharing the email of the speaker with you. Okay, so can you all see? All right, now for the survey form, yeah, so remember to fill up the e-survey in order you can get the e-certificate, right? So this is the QR for the e-survey, and our AJK will also post this link later in this YouTube so that you can fill up your form. Okay, so without further ado, now I would like to invite our first speaker for this morning, Puan Lee Saw Im. She is the Guru Cemerlang Kimia from SMK Seri Binatang, right, Utama KL. And Puan Lee is going to share with us using STEM fun learning activities to engage students in learning chemistry. So everyone, please join me in welcoming our first guest speaker, Puan Lee Saw In. Thank you. So Puan Lee, back to you.
Hello, good morning, and thank you, Ms. Fong, and thank you, Esme, for inviting me to join this workshop. Okay, so yeah, so my session, my topic will be using STEM fun learning activities to engage students in learning chemistry. So before that, I would like to just share with you about me. So this is me in 2016. I got first place K. Hajar Awards, and then 2019 awarded Global Teacher Awards, and then 2019 also got one honor of award for presentation in Dubai, and then this year recently during the MCO I got one second place popular writing in science competition. Okay, this little bit about myself. Okay, so today I'm going to share with teachers or educators about fun learning. To me, to have the fun learning with our learner, number one is to have the interest. So this interest is according to Sir Arthur Clarke. He says that if children have interest, education happens. Okay, and then after when they have the interest, so their curiosity will come. So it makes our brain more receptive for learning. So with the interest, with the curiosity, it will embark the creativity. So creativity means that the student or the learner can create new and meaningful forms of ideas. Then we are preparing our learners to lifelong learner. So education is not preparation for life, but education is life itself. Okay, this is a little bit about why I want to embark the fun learning with my student. Okay. Next, I would like to share what are the fun learning activity that I conducted in my school. during the MCO, the COVID-19 pandemics. So number one, I did home-based, you can see there, working from home, problem-based learning. So this problem-based learning is about plastic, the plastic waste. So as we know, the plastic waste is actually a global problem, right? So when my Form 4 student, they study about chapter 5 about chemical bond. So one of them is covalent compound. So plastic is actually one of the covalent compound. So I throw this problem to my student. So the topic is, I give them this topic about save our souls from plastic pollution. Okay, instead of doing giving lecture and lecture, so I change this lecture style into problem-based learning, and it is 100% virtual, because that time is during the MCO. So what I ask my students to do is they have to form a group, and then they gather information, they have group discussion, design idea, and then they need to do the presentation. So the design idea is they need to come out one idea, either they have one idea or maybe they innovate one tools to help to clean the plastic waste. So these are the outcomes for my students. So they are my children, they are very creative. They can come out a lot of ideas. They even got research from newspaper, from internet, and then these are some of the outcome from them. So some of them design using the coding, using design coding, and then they come up one activity or tools. That tools you can use to clean the plastic waste. Yeah, as I told you, this is 100% virtual. So the student, because as we know that MCO, student cannot meet each other. So they have to find their time to discuss, but it's virtually. Okay, so during this activity, we embark teamwork. We are focused on teamwork, leadership, and time management. They need to manage their time so that they can finish this project on time. And then they find way to solve problem. Okay, so during this activity, they use the digital skills. For example, they must know how to use either PowerPoint, Google Slide, and some codings. Okay, and then they can innovate a design. So this is the things that I want my student to achieve. So, and also after that, they can attend virtual Q&A. So I evaluate them. Yeah, they do the presentation using Google Meet. Okay, we have Google Meet, they present, and then I can evaluate their presentation. So during this activity means we can enhance 4C, and also we can embark the value, okay, about the global plastic waste problem. So out of this outcome for my student, 4 teams, I managed to send them for international competition organized by British International Education Association. This was the STEM Youth Innovation Competition. It involved 50 countries and 36 teams from the international final, and then 14 teams managed to go to the final. And Malaysia is one of the countries that managed to go to the final. Okay, I sent 4 teams. Then these are my students' achievement. So 3 awards we get from this competition. So we got my student was awarded as a Best Report Award, Best Video Award, and also Rising Star Award. The Rising Star is about top 3, but not top 3 yet. Okay, there's a very excellent project from my student. Okay, beside the problem-based learning, I also conducted the daily activities to learning in chemistry. Okay, for example, like preservation, fermentations, and about to compare soap and detergent. Okay, so I will show you the example. Yeah, this is one example about preservation. So instead of telling the student, okay, to do the preservation, you need to use the sugar, you need to use the sauce, right? So instead they just listen the lecture from us. So I turn the other way. They do this all activity, the preservation themselves at home, and then they take photo, either they take photo or they record the video, and then they do it in your presentation and submitted in the Google Classroom. And some of them even use the Microsoft Teams. Okay, this is one example. Another example, yeah, they come out like, you can see the design, very nice. They have tablecloth. Yeah, this is another one, an example. Okay, one more example. Okay, then here is, I show you the one class, I asked them to present in the class. So you can see the student can really present very, very well. They can show the step by step how they make the preservation. And even the boys also very happy to do that. Okay, and you can see them. They even bring their product to school, and after presentation, all they give to their teacher. Then I got a lot of preservative food to eat. So this is one of the daily activities that is fun for students. And it's a proof that what I say, the fun learning can engage students. Yeah, later I'll show you. This is another one. After my students have done this preservations activity, so one of I asked a few of them send their video for a competition. So one of the students, she got top 10 for international science videos competition. Yeah. So next one I will share with you is the fermentation. So this fermentation is the student just use any apparatus, whatever things that they have at the house. They don't need to go and buy the special apparatus. So like this pair of students, they are twins. They are twins. So two of them do the fermentation at home. So you can see, they even find the lime water, and they wrap the bottles with the wrapper and find a straw to deliver the carbon dioxide, so that it can show me the lime water turn chalky from the carbon dioxide gas released by the fermentation. So this is something that they can learn at home, yeah, without guiding of the teachers, and this can invite their creativity, and they find ways to solve their problem. For example, they don't have conical flask, they don't have rubber band, they don't have delivery tube, but they find way to solve the problem. Okay, so another example. Okay, so this boy, he also did almost the same, but when come to the presentation, he used a Minecraft. I also got a shock. Suddenly she showed me, teacher, this is my presentation. Yeah, it's so awesome, the presentation from this boy. Okay, and this girl, she managed to make both the preservative and also they make the tapai. This is the one that we always buy from the pasar, yeah, the tapai pulut. Okay. And then the next example is a comparison between the soap and detergent, the effectiveness, the cleansing as a cleansing agent. So this one also I asked my student to do at home, because at home they have soap, they have detergent. So this girl, very, very creative. She even did 3 comparison. So from the observation, we can see she really can prove that the detergent is actually more effective than soap in acidic water. So acidic, to make the water become acidic, she go and find the vinegar. Yeah. So this is another example, another girl. She also did quite well, and she even record the whole video. Yeah. So from this observation, you can see she really can compare. Okay, different. She can also can control the variables, the constant variable, manipulator variable, and also responding variables. So this is the one that we want our students to learning chemistry, and also they love STEM. Okay, so remember just now I said my character is fun learning in chemistry. We can engage our student. So before that, when I assign the assignment in the Google Classroom, frankly speaking, I will not get 100% turn in. But for this activity, for the home-based activity, I got a shock. I got 30 over 30 turn in. So they tell me the reflection, they say they love this activity. They really understand what is preservation, what is the function of preservative, the fermentation, and the differences between the soap and detergent. Okay, so this shows that fun learning in STEM, we can successfully engage students in chemistry learning. Okay, so I would like to ask teacher to do one. Before that, I will stop here for a while. Do you have any questions?
Okay, so ladies and gentlemen, do you have any questions for the Guru Cemerlang from SMK Suri Bintang Utama KL? Only.
Okay, so dear participant, you can scan this QR code. Okay, you can scan this QR code and answer questions. Wait, I shall move on. Okay, this one first. Okay, so please write 3 words about fun learning in this sharing. 3 words, teacher. Okay, you can scan the QR code and you also can, I already share the link. Teacher? Yeah. Okay, you can scan the QR code and you also can, I already share the link. Teacher? Yeah. Okay, you can scan the QR code and you also. 3 words, teacher. So this is one of the way that when we have the class, so make sure that our student read the instruction carefully. So like here, I say 3 words. Teacher try to give 3 words. Sorry here. Okay, please put in 3 words about the fun learning. How do you think about the fun learning? 3 words. Okay, never mind. Okay. Yes, that's great. Okay, interesting. Yeah. Hands on. Okay, come on. Some more. Okay. Yeah. Okay, interesting. The word that bigger in the middle means is the most people have post this word. Interesting, fun, and valuable. Okay, fun, engagement, understand, interesting. Okay, sama. Yeah. Okay, wonderful. Okay, problem-based learning. I love maths, meaningful, workable. Okay. Yes, come on, hurry up, teacher. Type 3 words only about fun learnings. What is the reflection about fun learnings? Okay, according to my sharing just now. Yeah. Do you think it workable in your school? Other subjects, right? Other subject is actually you also can use this method. Yeah. You can find some related to the real life activity and we can assign to the student, flip classroom, and also we can do as a home-based learning. Yeah. Okay. Okay, that's great. Motivated. Okay, I'll wait until at least I get 50. Can get more than 50. Okay, hurry up. I want to see how many people. Okay. The online, we got 113 people. So I wish that more people will write about this so that we can have the feedback. Yeah. Okay, so I will move on. Okay, one more. Yeah, one more person type in so that I can get 50 at least. Okay, one more is about, okay, I want to apply fun learning in my lessons. Do you want to apply this fun learning in your lesson? Okay, you can put the grading. You can read this. Okay, you can keep doing. So I will move back here. So challenges are what life interesting, and overcoming them is what makes life meaningful. Okay, so that is about my presentation. So now I give back to moderator for the Q&A session.
Okay, thank you, Wan Lee. We will continue with the Q&A session. So if you have any question, you may post it to the YouTube comment box, or you may email to the speaker. And now I would like to share with you the program book so that you can write to this speaker. Okay, so this is the program book Bengkel Perkongsian Amalan Terbaik Guru STEM dalam talian tahun 2020. So, dear participants, you can access to this QR code in order to read the abstract of the presenter. Okay, now another reminder is please fill up the e-survey form in order for you to get the e-certificate. Okay, so here we go for the e-survey. Okay, so do you have any questions here? We are going to have 10 minutes for Q&A session.
Oh, I can see the question here. What are the challenges you face for these activities? Yeah, so the challenges that maybe most of the teacher also face is some of the students might be they are not keen to participate in our activity. So in that case, so we as a teacher, we should become the motivator. We motivate them. We tell them the reason why they should participate in our activity, and give them moral supports. So for the slow learner, we maybe can give them more guide compared to the fast learner. Okay. How do you monitor the students' work progress during the course of their activity? Okay. So because I use the Google Classroom for this, my Form 5 student. My Form 5 student, I use the Google Classroom. My Form 4 student, I use the other platform. I use Microsoft Teams. So for both students, I can monitor them. Then during the MCO, I only can monitor them using the Google Classroom, using the Telegram. Okay, but after the MCO, after our school reopened face to face, then I can monitor them face to face. So I can check their progress. So the student, if they have any difficulty in doing their project, or they like suddenly, or maybe they don't have any idea how to start, then I will brief them, and maybe I will find some students, a good student, fast learner, and this fast learner as their mentor. This mentor can share their idea to the student that are having problem. Yeah. So like for example, let's say one reminder teachers, like let's say we conduct this home activity or home-based learning, we please remind our student they have or they must get permission from their parents. Okay, because if without the permission, later might be the student will mess up the whole kitchen and then they get scolded by the parents. Yeah, and we also should let the parent knows actually what is going on. Yeah, learning is not only in school. Learning actually can happen anywhere. It's virtually home-based learning, face-to-face or physical learning, even online learning also. Yeah. How long the time given for the student to complete the assignment? Okay, so the assignment is depends on what type of assignment. For example, like the first one I shared just now about the problem-based learning. The problem-based learning, because that time is MCO, so I give my student about 6 weeks. Yeah, 6 weeks, because they need time to get use of the virtual discussion. Okay, virtual discussion, and then they need time to discuss the ideas, get information, and design the tools that need to clean the plastic waste. How to teach STEM to KG student effectively? Is it KG means, what is KG mean, the kampung or what? Sorry, I didn't get what is KG. Mr. Welly, can you put your check at the text box so that I know what KG means? Yeah, kampung. Okay, if kampung, I think it will be lagi best bagi saya. So I speak in Malay pula, yeah. Actually, kampung lagi senang. Kampung, let's say you want to talk about, let's say the science teacher, maybe you want to talk about starch, or maybe you want to talk about paddy field, paddy, rice. Then you can take the student to the paddy field and they have a look at that. Or maybe like chemistry, I want to test what is the type of soil is suitable for planting the paddy. So they can take the sample and then they can test, come back to the chemistry lab and the test whether the soil is acidic, or what are the chemicals, what are the cation is contained in the soils. Yeah, that is good. For example, and maybe like mathematics, you can do a lot of calculation. For example, the chickens, right? Chickens. Okay, the chicken will control the food for maybe about 3 months or 1 month, half a year. Then we see which type of food can effectively or affect the lay egg from the chickens. That's another way of conducting the STEM activity. So after they control the food, they check how many eggs they can get per week or maybe per day. 1 day is 1 egg lah. Okay, per week, maybe how many. From there, they can compare. After that, they can draw a graph, right? They can plot the graph and then they can see which food is actually effective. Yeah. How about kindergarten? Kindergarten also you can conduct kindergarten. For example, like let's say you don't talk about food, you may talk about mathematics. Okay, mathematics, or maybe you talk about making car, making the car by using the recycled things. For example, the moving car by using the rubber band, and then use the roller, you make from the bottle caps. Yeah, and then you can actually teach the student about the elasticity of the rubber band that they use. Yeah, this another one for kindergarten. And answer your questions. Yeah. So It's actually, I wish that I can teach in the kampung school. I dream, because I saw a lot of teachers that they post their activity in the rural area. I think if one day I have posted now, I posted to the kampung, I think I wish I can do it also. Yeah. So one thing is when teacher, you design your activity like either the problem-based learning or home-based learning or flipped classroom, you need to let the learner, our student, know what is going on. If they know, then they will inspire, then they have the curiosity. We have to embark their curiosity. If they don't have any curiosity, then it's quite difficult for them to participate perfectly or 100% in our activity. Yeah. So besides they do one activity, maybe after that, their product, we can maybe ask them to sell the product. Then we can encourage them to become the young entrepreneur. Yeah.
Okay, is there any more question as the time is almost? Okay, can we have last questions here?
Yeah, last questions.
Okay, so I think last call?
Yeah, can I add one yeah, okay, moderator first.
So Puan Lee, dipersilakan, carry on.
Yeah. Okay, so before I end my session, I would like to say is that teachers or educators we cannot use yesterday's technology or yesterday's method to teach our today's learner, because we are going to rob their tomorrow. Okay, so I end my session lah. Okay, thank you. Oh, I saw my friend.
I think this is the question. Okay, so thank you, Puan Lee.
Yeah.
Puan Lee very much. And so appreciate that Puan Lee has shared her valuable experience and contributions of knowledge here. All right, thank you very much. The second guest speaker of today, is Dr. Savishwari and Miss Tan Pei Ling. Yeah, Dr. Savishwari and Miss Tan Pei Ling, they are the guru mathematics. Yeah, like Dr. Savishwari is from Chonghua, SMJK Chonghua Confucians, Penang, and Miss Tan Pei Ling is from SMK Perempuan Methodist. So without further ado, can we invite both of them to share with us the best method to do differentiations and integration? So Dr. Savishwari and Puan Tan, thank you.
Okay, thank you very much. So, okay, I'm Sarvis from SMJK Chonghua Confucian. My background is actually my research is more technical, reading geometrical diagrams. There are 26 technical variables. Okay, so later when I move on to Chonghua Confucian, so now I'm looking into STEM projects for AdMed students. Okay, so it took a quite long time for us to establish with this differentiation and integration. So I'll share a screen with you all to see what we have been doing for the past 3 years.
Surface?
Yeah.
I think the sharing is not done. I can still see you on the screen, but not your. Yeah.
Can see my screen?
Now I can. Now I can see.
Can. Okay. Okay, so we started with the program potency at Maths at Chunghwa Confucian in year 2018. Okay, then this is the program for the program potency. Okay, so later we upgrade ourselves with more important issues in differentiation, and we had presented at the ISTEM conference, carried out a workshop on differentiation. Okay, so these are some of the pictures. Okay, later on we carry out for the IPG Tunku Bainun pre-service teachers in February 2019.
Sorry, I interrupt you for a while.
Yeah.
Do you mind to put to the slideshow, because I cannot see the photo? Slideshow mode.
Is it okay?
Not the slideshow. It's still the slides by slides.
Sorry for the technical issues. Is it okay now?
I can only see slide by slides, not the slideshow mode. I think you need the technical team help, is it?
Yeah.
Charlene or Dr. Azida, can you help Savas? I think she has problem with the screen sharing. She has already has the screen shown on the but she couldn't.
Just click on the slideshow icon on the right bottom of the PowerPoint.
Yeah, she already clicked that.
Yeah, done, Dr. Zida, but it's a problem.
Okay, in that case, just make it bigger. Just make the slide bigger.
Okay.
At the bottom, you can just pull it to your right. Yeah.
Cannot.
Slideshow from the beginning. Okay. Dr. Sawe, when you click that from beginning, what will happen? That means when you try to click on the top of the right hand corner,
Okay, I think
it cannot work.
So yeah, there's some technical issues over here. It's okay. I will just, as Dr. Aziza said, I'll just make bigger.
All right.
Okay, so so this is the program potency at Maths in year 2018. Okay, then these are some of the pictures that students are doing their project-based learning. Okay, so in 2019, we presented the workshop at RC STEM. Of course, each time of presentation, me and Piling add on with more interesting things to our workshop. Okay, so this is in year 2019. Okay, then this is another workshop for the pre-service teachers at IPG Tunku Bainun in year 2019. Okay. Okay, so and carry on to my students in Chunghwa Confucian in year 2019. Okay, so it's quite a number of students. Okay, then we had this last year in April 2019. Okay, it was very interesting, and students really come up with many creative ideas that we didn't think of. Okay, so that's their own creativity. It's quite interesting with the product that they had come up with. Okay, so and we move on to the pertandingan inovasi at IPGPP, and we won a silver medal for this innovation of teaching. Okay, then we presented at Takeoff Mathematics in year 2019 for the teachers and also some of the district officers around Malaysia came to join us last year. Okay, and then we also presented as a workshop for a seminar STEM JPN PP last year in August. Okay, so these are some of the pictures. Okay, then this year we did the same workshop at a Methodist Girls' School, January 2020. Okay, some motivating, and the students were very motivated and very good feedback from the students. Okay, and from this differentiation, we came up with the idea of using some same techniques. For example, we use GeoGebra, but different concepts into applying for the concept of integration. So we find the volume, okay, of rotation. So this is basically all about our. Okay, so this is basically all about our workshops. Okay, so I pass on to Ms. Tan Peling from MGS. Okay, to further explain to you all the workshop on differentiation before then I'll come back to you all for integration. Thank you. I pass to Peling.
Yeah, thank you, Savas. All right. Share screen first. All right. So everybody, after you listen to what we have done here and there, so perhaps you actually want to know how do we manage to do that. All right. So I would like to share the screen with you now. Okay, entire screen. All right. Okay. So can you see my screen? Okay, I also cannot see my own screen. Yeah, Dr. Azira, can you help to share my screen? Okay. How come I have problem as well? Okay, StreamYard. Now I'm clicking sharing screen.
Your screen is now on.
Oh, my screen is now on. Okay.
Okay,
Wait,
share again.
I share again. Okay, I choose your entire screen. Am I right? Oh, applicable window.
Yes.
Okay, I saw already. Okay, share. Okay, can you see my screen now? On YouTube, I still see the
Yes.
previous screen.
No, it is now on.
Oh, it's now on. Okay, good. All right. So the very important part that we focus on is actually the 6E. All right, because every time when we plan for an activity, right, we keep on asking ourselves, what should we base on so that we won't left out, any important steps. So 6E here is our guidance that we use. Okay, so the first step of the 6E is engage. All right, so what do we do is that to get students to engage, we start by posing a real life problem. Okay, so the problem that we started for the differentiation topic is what you can see here. We have, as a canned food manufacturer, Mr. Brian wants to make a cylindrical can to hold 250 pi cm cube of soup. So find the dimensions such that the surface area of the can is as small as possible, so that the cost of the can is as low as possible. So here we engage the students to use their prior knowledge. So this game, or we should say that this activity is more suitable for the students who are already having prior knowledge in differentiation. So we wanted them to try out to solve this problem. And in case we have a weaker students that they are not so good at the prior knowledge, you can actually engage the students by asking them to explore using GeoGebra for the relevant concept that they need to use. Okay, so for this explore stage, students will be having headache because most of them who are weak in differentiation, they actually feedback to me that they don't know which one to use because there are so many different types. And then if you don't tell them that it's differentiation, my students will have problem as well. So what do we do here is that by having a GeoGebra that you can see here in my screen, I actually come out with this together with Dr. Savas, okay? So this one, can you see in my screen that this one is the very simple GeoGebra design that is having the idea of maximum and minimum. So we actually design a worksheet for this GeoGebra that the students can answer the worksheet, and then they can having to refresh back the idea on maximum and also the concept of minimum. Okay, and then during the discussion, we actually can lead the students to write out their solution, and also we can do it using window pane technique, where we get the first group of students to show the first step, then the second one to show the second step, and so on. So before we proceed to the second step, we will check on the first step first. So this is what we call by window pane, where the whole class of students will be solving one problem together, and we have students coming out to solve step one. Then before moving on step two, we check step one first. So that's what we call window pane technique for the explore stage. All right, so moving on, then the students will start to explain their solution once we have slowly come to the answer, where we find out what's the smallest radius and the height. All right, so the next step that we can use is to ask them to engineer. Basically, most of us, because of time constraint in class, after the stage of explain, we stop there. All right, and then we just expect our students to understand that, okay, the smallest radius is 5, the smallest height will be 10, for example. But then the student actually don't get the idea of creating or having the can holding on their hand. So that's why the engineer part will be another new stage where we should move on, actually, because after we have experienced it with so many different group of people, the process, or we should say the step of creating the model, actually help all these students to get a better idea, and they can visualize that what is the actual model that they deal with. Okay, so that they can come up with the smallest possible surface area, or and also the smallest possible volume. All right, to keep the 250 pi. Okay, so here for the engineering step, I have a photo to share with you here. This one is a really engaging process where you can see students start to measure. And there's one thing that is interests me and also Savas, is that even when we deal with teachers, right, when they are constructing this model, some of them actually, when they found out that the radius is 10, there's one group of a teacher, they actually, when they come out with this model, right, when they are measuring our manila card, they actually cut out 10 cm 10 cm rectangle, because to them, they thought that when they have radius 5 cm, they just have to cut out a 10 cm rectangle to make up the cylinder, which actually, they realized that after they cut it out, they realized that that doesn't give them the cylinder that they wanted to, because the volume, the radius of the 5 cm doesn't give you what you need for the can. Okay, you cannot construct out the can properly. So they realized that actually when they cut out, they have to measure out. So they themselves actually reasoned out that they should measure the circumference with a radius of 5 rather than cutting out the diameter of 10 cm. So that actually shocked them as well. And we also find it interesting because once we never asked them to really construct or create the model, right? Actually, we have very weak part of imagining 3D stuff. All right, so that's what that interests me as well. So by creating the model, actually students start to engage more and they find it more interesting. All right, same goes to my students as well. So here I would like to show you another step. Okay, after we engineer the model, actually the enrichment part is also important, because after you create the model, of course you're interested to find out whether the volume here, is it the same as what you planned. Okay, so verifying the volume is the next step here. Okay, all right, where students start to verify it by using flour, because we are considering costing and all that, so students only use Manila cut. That's why soap is not possible, because it's liquid. So we are using flour to let the students test out the volume. So that's why they start to test out the volume, and then they measure, and then they actually feedback whether do they get 250 pi or not. Now at this step, actually I also encounter some interesting part of the whole thing, where the students actually thought that the 250 pi cm cube is 250 gram. All right, so that's throughout this process, right? No matter you have very strong or weak students, you actually find out something interesting, where students tends to make a lot of assumption, which is a misconception inside them. So from all this process, the students, they themselves realize, and among discussion that going on, so it actually helps them to improve their own, and they correct their own misconception. So this picture that you can see here actually is before MCO. It is in February this year. All right, during the school, my MGS school, we are so fortunate to have this learning festival that we used to have, and also with the support from the school principal Ponli and also our PIBG, we actually managed to have it almost every year, the learning festival. So the students actually benefit a lot. Okay, this is the feedback given by them. All right, so the next one, after you have engaged them, and then you let them explore the concept, and then they start to solve it, and they explain to their peers, then they start to engineer. Then now it comes to enrichment, where students verify the volume using the flour, and they reason out the difference in terms of the volume that they get. So we start to get them to evaluate whether what are they doing, is it making sense or not. Okay, is it to them, does it actually equivalent, when you actually use flour to represent soup? So this is what they never think about, because sometimes students tends to follow what the teachers is sharing and teachers instruction. So they don't actually think about it until we actually ask them, do you think that the density of flour, or rather the mass of flour that you just measured, is it equivalent to soup? So students will start to give some thinking into that. You will at first listen, you will hear that there's a piece of silence, because like students also never thought that, is it actually equivalent? So from this part here, you can actually start another round of engagement if your time allow. Okay, so that's why throughout this process, right, this 6E is actually an ongoing cycle, that you don't just stop there. All right, and also it actually boosts the students' confidence to actually even explore more, but provided that you need to give them guidance. Depends on your students' ability, I would say. All right, so so for my sharing, this is our part, okay, where we just a small attempt from our end, because I do understand that time is always a constraint for us, especially now. We have so many chapters to cover, and then I myself also, I'm an ordinary school teacher. Okay, I'm a maths department. I'm maths panel, the head of maths panel, Ketua Panitia of my school. So I actually want to try to, different thing, so that I can also motivate my colleague in school, so that everybody will start to try out something new. And for my school, the school learning festival is a good chance, to expose students to all this. So perhaps for my fellow audience who are listening to my presentation, you can actually try to find time, where your time allows, maybe, that you can squeeze out some time to do this, because this process of 6E, it depends on how you want to adjust the time for each part, each step, so that at least, because actually the explore, for example, using the GeoGebra, you can do it, allow the students to do it themselves if you share with them the GeoGebra, the software, okay, and let them explore themselves at home, so that you can save some time, so that you come to class, you just explain to them, so it can actually save some time here and there. So it depends on the wisdom, okay, to try and then squeeze out some time, okay, just to give it a try. Then you will actually see difference in your students, because most of my students, they feedback to me that they don't actually see why are they learning differentiation. So after this activity, I would say I tried it with 30 something of my students, all of them, okay, 35 of them in fact, okay, 35 of them told me that yes, they actually benefit from it. They now see why are they learning minimum, the concept of minimum, okay. So yeah, so with that, I would like to pass back to Dr. Savas, because we have actually moved on with integration. All right, yeah, so that's all for my sharing this part. Okay, so Dr. Savas, can you share a bit on integration?
Okay, thank you very much, Pei-Ling, for the explanation on differentiation. Okay, I've shared my screen. I hope can you all see my screen? Not yet. Okay. Yeah. Okay, so now okay, well, let's have a look on this. Actually, there's some technical issues over here. Okay, so for the part of integration, okay, so we are using the 6E. So the first one, of course, we engage pose one real life problem to the students. Okay, so this is a workshop that I have done during the COVID-19, during the pandemic. So it's during the MCO. That I have done during the COVID-19, during the pandemic. Okay, so when I pose a problem to the students, okay, first I pose a problem asking them about, okay, do you know the purpose of learning integration, or how do we apply in daily life? Okay, so normally when we teach in school, okay, we try to, we give them the formula and ask them to do the integration, find the volume, find the area under the graph. Okay, but they do not know the purpose of learning the concept of integration. Okay, so these are some of the outcome from the students. Okay, I do not know, ha ha ha, then I don't know, and tak tahu. Okay, just some of the examples. Of course, because we are trained, this is the old method, like what Puan Lee told just now. It's the old type of teaching. We are more on to the exam base, right? So they do not understand why do they need to learn integration. So I posed this question on: calculate and verify the volume of a cylindrical shaped object from your kitchen using the formula of volume pi r square h. Okay, so they knew that the volume of a cylinder is pi r square h, but now I told them, you don't use the formula, and can you calculate for me the volume of the cylinder? Okay, so here I didn't mention that this is an integration. So let the students to think first. Okay, then they try to come up with a conclusion of, teacher, why not we can use integration. Okay, so there's some discussion before that. And okay, so next is we explore the concept with my students. Okay, concept on the objects, the volume rotated. I'm very sorry, I have to go slide by slide. There's some problem with my sharing. Okay. So the concept, volume rotated towards the x-axis. Okay, so at first I give them this diagram, okay, and ask them to try to look at the what is the relationship between the product that they have in their hand. Okay, for example, I have over here, this is a lipstick, a cylindrical shaped lipstick, right? So I discussed with them what are the other things that they have from the kitchen. So this is not from the kitchen. So they gave me like this one, the beans can. Most of them gave me a cans. Some is with what we call blender. Even though blender is not a cylindrical shape, but it's a very critical discussion with them, how to find the length for rotation in integration, to use in integration. Okay, so the basic one for them to understand the concept is cylindrical object. Okay, so let's say here, I showed to them this diagram. Okay, what is the height and the radius? Okay, so they can relate it with the product that they have in their hand. Okay. Then we go to the 6 bag. Okay, again we try to explain to them with the measurements. Okay, so we have the measurements over here. Explain to them the radius and the height. Actually, I just let them do, because they are Form 5 students. I let them do and explore. Okay, actually, they came up with all these things. I did not ask them, I did not mention to them the method of measuring the height and radius. Okay, just let them explore and do it by themselves. Okay, so they put their tin over here, do the circle. It's more to like what you call creative thinking. Okay, they think about how to get the radius and the height. Okay, so they use their compasses, protector to measure. Okay, then this is the radius. Then they showed me their height. Okay, again, I want to repeat, this is during the pandemic, right? So I limited to only 10 students per session. Okay, so I had 3 sessions, limited to only 10 students per session, because I wanted to see each of their outcome. I asked them to share their product, their outcome. So if too many students, because this one they're doing online with me, if too many students, it's very difficult for me to observe, because everyone having different things. Okay, some with cans, some with what we call bottles, drinking bottles, cylindrical shape, and some with a blender. It's quite interesting. Actually, they are very interested with this, with all these things in their hand. Okay, so I am limited to 10% each session. So they measure and showed me how to do the working. So this is a randomly picked students' outcome. Okay, next is the engineering, the model, creating the model. Okay, so of course this is apart from the differentiation. Actually, in differentiation they have created this model of cylinder. Okay, so even though they don't have this in hand because they were at home, so we use other products, as I mentioned earlier. We have all these things. Okay, and especially these beans, measuring cylinder, and so on. Okay, so the engineering part we can actually discuss with the student if we do not have time even in school. Okay, so this whole session of integration I took for about 1.5 hours. Okay, because I need them to show part by part in their sharing session. So the engineering part, we can go for discussion, okay, where we can go deep into critical thinking, where it's not a cylinder. We can go for other objects, which is not a straight line over here, okay, because this is another method of why do we need to use integration. Okay, for example, cylinder, yes, they know it is pi r square h is the formula for volume. What about other things, other products, which they haven't learned the volume? Okay, so how to overcome with the equation for the y-axis. Okay, so we had some discussion over here where they can really understand why do we need to use rotation under the graph to find the volume. It's quite interesting. Okay, next is we enrich with a GeoGebra software. Okay, this part, the enriching part is this enriching part is I share with them the coding for GeoGebra. Okay, so actually they already have the software of GeoGebra because previously we used linear programming to learn. They learn linear programming with GeoGebra software. So over here they already have the GeoGebra software. I provide them the coding. So with the coding, they can come up with their cylindrical shape, and they can pull out the H and R value to see the difference of volume. Okay, this is actually to enhance their understanding on volume and the relationship with radius and the height. Okay, and the next part is, okay, because you might be thinking this is a STEM, I wrote it's a STEM, right? So we use technology over here. Actually, they can learn many things with GeoGebra software. Okay, then evaluate. Okay, so the evaluation part is the last part where they need to calculate. Okay, so over here, they calculate the volume of their cylinder. Okay, so they already measure the radius and the length, the height. Okay, so actually they can come up with the formula of volume, and I also help some of the students where v equals to pi 0 to x y square dx. Okay, this volume, of course, they all know and they can write it out for me. So I ask them to relate it with the measurement that they have. Okay, so since I let the shape to be in horizontal like this, right? Okay, so the height would be, the length of the height would be the length of the x-axis from 0 to h. Okay, the h value would be the maximum value of x. Okay, so over here they use 0 to h y square dx. This is the formula that they learn in school, the concept of integration for volume under rotation. So they apply what is the value of 0 and what is the value of h from their measurement. Okay, and what is the value of r? Okay, so y is equals to r, that means y is equals to the radius. So it's a very simple formula for them to understand. Okay, the basic thing is here is that I want to make them understand how do we integrate volume, where we use integration with the real volume that they use. Okay, so we use a very basic thing here is the radius. Let's say the radius is 7. Okay, so 7 square, they use here 7 square. So when you integrate, you get 7x, right? Okay, so they write out their calculations. Okay, so these are some of the screenshots of my students' work. Okay, I screenshot, I ask them to show, and here I also ask them to explain. Okay, when they explain, they understand well why they're using, where they're using their R, 0 to H, and why are they using integration to find the volume. Okay, it's quite interesting, and students really, they understand well the concept of integration. Okay, so the last part would be checking and conclusion. Okay, checking and conclusion. So over here, this is one of the sample for checking and conclusion. Okay. Okay, so this is one of my students wrote on the screen. I use Zoom. Okay, he wrote over here, teacher, my tin states 300 gram. Okay, so but my calculation shows 297.2198 gram. Okay, 1 cm cube. So this is a very interesting and critical discussion for students. Before we discuss and some students giving feedback, and before I give a conclusion, it's quite interesting that the student itself came up with the conclusion that because I measure the outside of the tin. Okay, so the thickness, this is because of the thickness of the tin, right? So because I measure the outside of the tin. And since the food is in the tin, so the volume is less. Okay, so all these are the critical discussions for project-based learning. Okay, so it's this is a quite interesting sharing with them for the topic of integration. Okay? Okay, so the last part would be conclusion with my students. Okay, I pose another questions, asking them that so why the volume is different. Okay, so a discussion with my students to get back to them why do they learn the concept of integration, and it was a very good sharing with my students during this pandemic through online. Okay, so thank you very much. This is all about our workshops done. So I get back to the MC, the moderator.
Okay.
Thank you very much.
All right. Thank you, Dr. Savage, and thank you, Kuan Tan Pei-Ling. Right. Now is the Q&A session. Anyone got any questions here? We have 10 minutes for the Q&A. You can post your questions to the YouTube comment or email directly to communicate with the presenter. All right, so you can actually get the presenter abstract. To read the presenter abstract, I'm going to share my screen with you. Okay, so dear teachers, you can actually go to this buku program Bengkel Perkongsian Amalan Terbaik Guru STEM dalam talian tahun 2020 to obtain the teacher's abstract. And if you have any questions, please kindly post on the YouTube comment box.
Okay, you're most welcome, Liza Kozanan. I hope I pronounced correctly.
While waiting for questions, right? Actually, I just want to add on a bit. All of us are busy, actually. Yeah, we all understand. So what we are doing here is just one small step to try with the students, and you will actually get quite different feedback, and then you will see some different reactions from the students where they will become a little bit more confident, at least in AdMaths, because AdMaths could be quite difficult to students, from their feedback. So yeah, just let us try together. Yeah.
Okay,
Yeah.
sorry, add on to Pei-Ling's one. Actually, for the differentiation part and also for the integration, when students learn with these hands-on activities, they will actually remember how to use the value of maximum, minimum in their daily life, and also for integration. Because SPM questions, normally they won't say that use differentiation or use integration. Find the maximum value and minimum value. So with this activity, automatically students can know, can relate it with the concept of differentiation and integration.
Okay, dear participants, do you have any questions? Right, so calling once, calling twice, calling off. Okay, all right. Yeah, thank you to Dr. Savage and Kuan Tan Pei-Ling for the valuable sharing. It is really inspiring, and especially mathematics is very challenging. Right now, I think we have one comment from Miss Sarini here. So, Dr. Savage or Kuan Tan, would you like to provide your feedback here? Thank you.
Okay, thank you very much.
Okay. Savas, this one would be more to, we can use Zoom, right? Would you like to answer a bit on this? to use 6E and RMCO SOP observe. Yeah, thank you, Puan Savani, for the question.
Yeah, you can. We can do online. Okay, we can do online for your. Is it for your means for your learning festival? Pei-Ling? She means for your. Okay.
Actually, I think these are not just the learning festival. Learning festival is just one of the platform for us to, do this more unusual activity, more to exploratory or in during this RMCO period, right? Actually, the 6E can still be on. All right, even like online, because if you look back at Dr. Saveswari sharing, right, the first step of engaging can be done when you post a question to your students, even through email or Google Classroom. Okay, just post to them and then give them some time to explore themselves. Then I would suggest that you can have an online session where the students actually explain out or share out. Actually, even you do it offline also, I don't see a problem there. Where until the stage of explain, where your students can actually explore the concept on themselves, provided that you give them relevant material, and then you explain, or they themselves explain to you through their working on how they actually solve. Then I think the engineer part will be, you have to engineer out the model, let's say for the differentiation part. For that one, maybe you can have one session online with the students so that they can do it together, and then the enrichment will be together with the students and draw a conclusion. I think it can be done online.
Pei-Ling, I continue with yours.
Right? Yeah.
Okay.
Yes,
So actually, during the MCO, everyone do together the hands-on activity, right? So I have each batch of 10 students. Sometimes when they do together, actually they're very excited, because their friends are there online also, since they were at home, right? So they're very excited to show, they're working not to me, actually, to their friends to discuss among themselves. It's quite fun. And I get back to Dr. Kong about how to evaluate the students' outcome. Okay, actually, even for differentiation and also for the integration part, after our workshop, we have posed some hot questions to them, okay, where we did not mention that these questions need to be integrated with differentiation. Okay, we post to them, for example, for the differentiation part, we gave them, okay, how to find the maximum number of X to get the value of 16. Okay, some type of simple questions, but it's a higher order thinking skills. And for example, how to find the minimum value of a container. Okay, but that is some sort of same with the, for integration also, we have some problem solving questions after the workshop. So after the workshop, the students were able to solve where, because they can really understand, okay, the working or methods. Of course, some students are weak, they can't do the working, that is their technical part actually, but the most important thing is that they understand what the question is asking for, because these hot questions doesn't straight away ask or tell them that this is differentiation or integration. They have to read the question, understand that they need to use or use the concept of differentiation, and for this question they need to use the concept of integration. So that is the main reason why we do this hands-on activity.
Okay.
I hope that Dr. Kong, I've explained.
Yeah, can I add it to that also? So actually, I have several sample here. So the evaluation can be done in terms of two aspects, I guess. Okay, the first one will be from the model that students construct. Basically, you can see they have different measurement, because we have actually make it variety a bit, where we give different heights to the students with the fixed radius. Okay, so in that case, right, when students come out with the part where students also can start to measure their volume. So from there, they can see what is the volume that they actually obtain. All right, and then they test it with the flower. That's the first step. The second part is that we can do more enrichment questions, which is similar, but we change the number. So when we change the number, we let the students work it out again just by changing different number if the students are able to come out with the solution. So they actually gain more confidence from there. And last year, SPM 2019, I think in paper 2, one of the question is on this differentiation and also integration using the cylinder, right? Am I right, Dr. Savas? Yeah, so that part actually it helps the students to relate what they have done here, okay? So that that's the part that for evaluation. Hope that I answer the question. Yeah, Dr. Savas, you have anything to add on?
No, any questions from the audience?
Yeah,
And
anyone?
pass to the moderator. Listen.
Can we have the last question, please? Okay, so I'm going to count 3 times, then we will move on to the next presenter. Calling once, calling twice, calling off. All right, so thank you to Dr. Savage from SMJK Chonghua Confucian, Pulau Pinang. And thank you to Kwan Lee Tan Pei Ling from Methodist Girl High School, Penang. Right, both of you are really very passionate teachers that share with us this valuable information and knowledge. Right, so I'm sure everybody enjoy that. All right, thank you.
Okay,
Right.
thank you so much. Thank you very
Yeah.
much.
Thank you.
Thank you. Right, so without further ado, now can we invite Dr. Chin Chi Kyong? Right, Dr. Chin Chi Kyong is the lecturer from IPG, Institute Pendidikan Guru, Campus Tuan Fu, Bainon. And he is going to share with us an interesting topic this morning. And the topic is called the student voice in science education. So without further ado, shall we put our hand together on the air to welcome Dr. Chin. Thank you.
Good morning, everyone. I'd like to thank ASMAP for having me. Let me share screen. Okay, the message that I like to share with everyone here is student voice in science education. Being teachers, we provide service, all right? We provide service, and student is our main stakeholder. In fact, they are our client or customer. And in business, we always say that the client is always right, right? But it's kind of sad in education that students' voice may not be given the right emphasis, and but it is very encouraging to hear sharing from Ms. Lee and Dr. Savas and Ms. Tan, the way they have conducted their chemistry and maths lesson. It was a very enlightening, eye-opening experience. I think a lot of our teachers here are learning a lot of best practices from them. So essentially what is being done here is that we are giving students their rightful place in education. We want to hear their voice. All right, in the presentation that we have seen earlier, a lot of slides, you know, you see the students doing the presentation, the students having ownership in the education that they are going through. And also maybe to put a matter in a different perspective, all right, to look at student as being client, okay? Now, when we go to a hairstylist, all right, we go to a hairstylist, we are the client, we tell the hairstylist, you know, how we want our hair to be styled, right? So we go to a tailor, all right, we tell the tailor how we want our clothes to be tailored according to our body shape and size and design. And even when we see doctors, all right, when we see doctors with our health problems and all that, all right, we are the client, all right. The doctor would tell us the condition of our health, but it is us, when we are the client, we are the one who decide to heed or not to heed the doctor's advice. Doctor may say, okay, we find you with a cancer, you can do chemotherapy, you can remove the organ, you know, eventually it is us, you know, who decide. So I hope I'll be able to share the importance of a student's voice in science education or STEM education for that matter, all right, from a teacher education perspective. Now, this online news came out about exactly 1 year ago about the Ministry of Science and Technology during that time worrying about the dwindling enrollment of science students in Malaysia. All right. According to this news article, student enrollment in secondary schools, all right, in science stream has dropped from 48% in 2012 to 2018. We have only 44%. In Malaysia, we have this initiative, the 60-40 initiative, right, to have 60% student enrollment in science and 40% student enrollment in arts, but it seems that the reverse is true. And in 2017, all right, student enrollment in higher education, all right, we see only 37% of students choosing science, maths, computers, engineering, manufacturing, and construction as their choice of study in university or colleges, and 63% in arts and humanities. The STEM education in Malaysia, all right, aims to create a STEM literate society and also to train up a highly skilled STEM workforce, all right, for innovation towards a progressive society. In Malaysia also, we have the Malaysia Education Blueprint, which have identified these 3 core measures, all right, to achieve the aspiration of a STEM education in Malaysia. Number 1 is to raise student interest in STEM subjects. Number 2, we want to improve teacher skills. And number 3, we want to build public and student awareness. So later on, when I share 2 case studies, okay, I'll be looking at the core measure related to raising student interest and also in improving teacher skills. As I share these 2 case studies, I hope you can also relate to your experience. Being STEM teachers, science, maths, teachers, we have been STEM students, in earlier part of our life. So you can recall your experience learning science at the primary school level, secondary school level, from 6th college level, or even university level. How was your experience like? Do you have increased interest and excitement, passion about science, mathematics, engineering, and in general STEM? Or do we have do we find the subject getting boring, more difficult, more challenging? That's one thing as a student. And now that we are STEM teachers, we can also relate our experience to how we conduct our lessons in our daily lessons. Right? Do we provide the experience that the students enjoy? Do our students fall asleep in class, not paying attention, showing all kind of discipline problems and all that? How have we been conducting our science, our maths lessons? In case study number 1, my focus is on raising student voice in science practicals. Now we know that science practicals are very important. All right. In fact, maths also have their way of doing practicals. Practicals help students to get a hands-on experience. All right. It helps students to build their knowledge and understanding about science concept through some conceptual framework. It also motivates students, and it also helps students to improve on their manipulative skills, how they use tools and apparatus, in the lab and all that. So it is very, very important. Now let me show you. This is a typical, or can I call this a classic experiments in a physics lab? All right, you want to study the relationship between velocity of motion and the angle of incline. So we give them the aim, identify the variables. We provide students with a trolley, protractor, ticker timer, ticker tape, and we provide students with all these things. And also we provide students with a prescribed fixed method that the students must follow. All right. So this is step 1, step 2, step 3. We are very familiar with this in school practical. All right. We give students a diagram, we give them the procedure, and they are supposed to follow obediently. Okay. This is another example, very classic. You want to study the effect of a mass of an object with this on its acceleration when the force applied is constant. Again, you have the diagram. We provide all the things needed, and then we have a prescribed step by step of what to do. So in essence, when we provide students with these kind of things, this is actually teacher's voice. Teacher is directing students what to do in the practical. no doubt later on in the discussion, usually we have some questions for the students to discuss. All right, but then again, students' voice is not really heard here, right? Because still, all right, even though the students are performing the practicals, but they're following these prescribed steps, so they don't really have a say, you know, in what is supposed to be done. They have to do step 1, step 2, step 3, and so on. All right. Now, so when we want to highlight on a student voice, one thing we have to bear in mind is that we have to tune down the teacher voice. When we want to put emphasis on a student voice, we have to diminish teacher's voice so that students' voice can be given the rightful place. I'd like to share with you what we found or what we observed when we raise student voice and reduce teacher voice in science practicals. All right. Now, number one, we find that when students do perform these classic experiments in physics, all right, they have different ways of setting up the ramp, all right, the runway. All right, over here you can see this student use only one retort stand to hold the ramp. The student at the group at the back have 2 retort stand to hold both sides of the ramp. Later on, you also notice in other pictures some students use bricks, all right, to support the runway. All right, this student bring it to outside the lab. All right, I believe they have their reason of doing that. Okay, so this is what you observe. All right, when we raise students, what that means, we tell students do it your way. All right, and then they will start exploring, doing the classic experiments their own way. Number 2, they are in one of the experiments. They're supposed to apply constant force. All right, when they let down the trolley. So over in the classic procedure, they use the rubber cord, you know, and all that. But now students are exploring different ways. Whether the method works or not is a different matter. But now they are exploring different ways of applying constant force. So one student try to use this method, all right, use another ram, all right, to press against, all right, the end of this trolley in an attempt to apply constant force. Another student, look at this student, all right, this group actually make use of the 2 retort stand and then with the rubber stretch in between and try to apply constant force in this method. So they come up with different ways of doing things. Okay, and then it comes to manipulating variables. The classic example will tell you to stack up, okay, you use 1 trolley, 2 trolley, 3 trolleys, 4 trolleys, and see what happens. But then when there are 5 groups and there are limited number of trolleys, right, they have to find different ways of increasing the mass. And over here, the students are using chunks or blocks of plasticine. All right, so they manipulate variables. All right, they do it their own way. Okay, and then some students thought that it is important to draw a starting line. Right, to draw a starting line. All right. Okay, this is not actually prescribed in the procedure, but they thought it is good to mark a start line so that they know exactly where to put the trolley before they let it run down the ramp. And then also, you know, the problem with the trolley is that when the students do this experiment, they let the trolley run down, it will hit the floor. So I raised this concern in my class and said, you know, if you do this, after some time, all the wheels will come out, and then in future, the future students won't get to use the trolley anymore. So I asked them, how can you minimize damage done to the trolley? All right, so some students, all right, instead of letting the trolley hit the floor, they actually block the trolley coming down with their shoes, with their leg. All right, so that's one way of doing it. Okay. I think this is better than, you know, let it hit straight on the ground. All right, and then another student actually used bricks, all right, at the end of it, but realizing that brick is also a hard surface. So this student actually put the feather duster, all right, so that when the trolley hit, all right, the bricks, at least, you know, the impact is not as damaging. Okay, and then I did not provide them with the protractor. I want to see how they want to adjust the angle. All right, and to my surprise, the students found out that there are some apps that they can download on the phone and measure the angle of inclination. All right, so one group came up with this Angle Meter Pro, in which you have to place the your handphone, you know, vertical to the ramp, and then there was yet another app in which you put the phone lying flat on the ramp to measure the angle of incline. All right, so I'm really surprised with this. I thought they would be using some mechanical way of doing it, but to my surprise, they found apps in doing this. And also maintaining alignment of our sliding trolley. All right, so as our car tires, after some time we have to send our car to the service center to realign alignment, all right, of our tires. So the same problem happened in trolley. When the trolley is let down, and if the trolley is not moving in a straight line, the trolley will hit the side of the ramp, and the trolley will stop, not able to travel the distance that they're supposed to move. We cannot calculate the velocity and all that. But this group, all right, make a very minor adjustment so that the trolley is able to move in a straight line. And I did not expect them to do this. All right. Okay, so obviously trolleys have alignment problem on the wheels, but the students just place the position differently and they solve the problem, and the trolley could move in a straight line. Okay, so the main point I like to highlight here from the case study number 1 is how to raise student voice in practical, especially in classic practicals, right? So what we can do is empower students not to follow procedures strictly. Very often we expect students to follow procedures strictly, but at times, of course, as long as safety concern is not breached, all right, because some procedure, that, for example, in chemistry and involving electricity, all right, safety is very important. But if safety is not compromised, then we should allow students, or in fact, not to say allow, but in fact, encourage them not to follow procedures strictly, encourage them and tell them it is okay to deviate from prescription. They can explore different ways of doing things. And when I encourage them to do that, I see many different ways of doing things differently in the lab, but they're still getting the results. Okay, and then we can intentionally take away some material or apparatus needed in the practical so that they will start thinking. All right, I remember Miss Lee in our first presentation talked about how her students, when they don't have the rubber bound, and they don't have material they need, how do they overcome it, right? So that is what we want. When the students do the thinking, take action into their own hand, this is the kind of student voice that we want to see happening in our science practicals. And then entrust problem solving to students. Very often when students encounter problem in practical, they will come to the teacher, this one won't work, what should we do? And then very often we will be very eager to tell them, you should have done this, you should have done that. But what we should do is we should hold ourselves and throw the questions back to the student, ask them to figure out, ask them, what could you have done better? Do you want to check how you set up the experiment apparatus? So we throw the question back to them because they are able to come up with solutions, and very often the solution will really surprise us. All right, so don't be eager to solve problems for them when they face difficulties in practicals. And of course, when we allow students to explore, we have to be fair to them. We must allow them more time. We must give them maybe recess time or additional periods or after school, for them to explore, because when they explore, they are bound to make mistakes. And that is exactly what scientists work, right? Scientists explore things in the lab, and they have to try so many times before they actually get things right. So this is what we want the students to feel, to explore, all right, and then to develop this intrinsic motivation, all right, to try out different ways of doing things instead of following prescribed methods rigidly, in a very rigid manner. And it is also important that we as teachers, we should emphasize on the journey of exploring instead of highlighting on the expected results. When you do experiment related to F equals to MA, the graph that you plot must be what is expected. That is, for me, that is that should not be our emphasis. Our emphasis is to let them have a voice in how they determine, how they carry out the experiment, how they want to modify, how they see problems, how they problem solve and all that. So the emphasis should be on journey of exploring, not on the expected outcome. My second case study is about coaching teachers for a STEM project. Now this is different from the one I've written in a synopsis, because later on I found that this is more relevant for our sharing purpose today. All right, we had the privilege of working with some schools. All right, in this particular case, we managed to get Form 2 math and science teachers, all right, who are willing to work together to come up with science project for their students in Form 2. All right, so for the science teacher, the topic that they have selected is about simple machine, and for maths is statistics. All right, so we want to see how you can do transdisciplinary or interdisciplinary, whatever you want to call it, between science and maths, and come out with a STEM project for students. So the student is supposed to design a simple machine to help school cleaners to pick up garbage. All right. So the first thing they do is they survey the type of waste. So they go to the dustbin. All right. They start to dig out things, and then they want to know what are the what kind of waste are being thrown into the dustbin every day. All right. So the students do that, and then they presented. All right. They're finding in using statistics. All right. So over here, instead of students performing, routine exercises from the textbook, all right, the student actually created a table or pie charts, all right, to represent what they have learned, all right, based on a real situation. And then after that, they design a simple machine, right? They design simple machine, and then of course, when you talk about STEM, the engineering part of a STEM will involve engineering, or design process. All right, so they go through this process, they come up with prototype, and then they even show their classmates how their simple machine would help the school cleaners to pick up rubbish or to clean the school. All right, they come up with different tools. Right, this one look like chopsticks and all that. Okay, and so as I like to share our experience helping school teachers. All right, so I think as school teachers, doing STEM education or STEM approach is something that we are not very, very familiar with. All right, but hopefully we are encouraged by our fantastic speakers earlier and speakers to come, how they do things differently, and we hope to get more teachers, all right, to do science in a very different way, in a more engaging way. All right, and we give the role back to our students. Okay, so what you can do is this. You probably need to have a mindset. All right, teachers need to have a change of mindset. That one of the I think Miss Tan mentioned earlier, we cannot use the old method, that the way we learn science in school for today's students. It doesn't apply anymore. So we have to change our mindset that the way we teach science may need major revision. We need to revise the way we teach science, the way we conduct lessons, the way we do practical with our students. We must be ready to embrace change and be ready to compromise on our practice in our comfort zone. Very often we teachers, we like to be the sage on the stage, right? We like to be standing in the middle of the class. We are the wise man or wise woman in the class, and we deliver the content, and then the students just sit and passively listen. Of course, that is so out of date. So we must be ready to let go of such thought. That sometimes if you don't teach, are the students learning if I'm not teaching? When the students are doing these projects, are they really learning? All right, so we have a lot of worry and concern, and then we couldn't let go. That I must be in control, I must be in charge. So we have to stay out of the center stage. We have to hide behind the curtain. Sometimes we have to get down from the stage because we want to give the stage to our students. We have to change our mindset about our role. All right, we are no longer doing a teacher-centered science lesson, but we are doing a student-centered science lesson. We want to give student voice its rightful place. All right. And then if you're not ready, you can engage a coach or a mentor. We have a lot of experienced teachers here. Later on, you can contact them, now with Zoom and all that, online consultation is available, right? So you can engage a coach or a mentor. They'll be very happy to share with you, especially when you do not know where to start. And along the way, you might need some advice when you encounter hiccups and challenges. Get a willing partner, because you might be teaching science. You want to get a partner who is teaching maths, maybe another person who is teaching different aspects of STEM subjects. Get a willing partner. That's very, very important. All right. And then the next one is a school visit or field trip, or getting involved in networking, attending workshop. All this is very important to widen our horizon about projects and ideas that we can use to improve our teaching. All right. To highlight the importance of student voice. And don't forget to incorporate design thinking. Very often in STEM, when we don't put the element of a design thinking, right, the STEM part doesn't really show. So there must be a design thinking, all right, that is involved in a STEM project, in a STEM education approach. And additionally, to make things even more interesting, to add aesthetics value to it, some soft skills in presentation using digital tools and all that, you can add art to make STEM become STEAM. All right, so the art element is there. There's probably better avenue for students to show their creativity when arts comes into the picture as well. Okay, I like to highlight the role of school administrator. If any one of you happen to be, a senior school teacher or even a senior assistant, or you can even bring this up to your school administrator in order for us to encourage teachers to get involved in a STEM education, STEM project and all that kind of thing. We might want to consider, in fact, I think we should seriously reduce the workload of some of these teachers. Maybe the number of days they are on duty, whether they need to stay back in the afternoon for sports practice. Now, I'm not saying that you will use this excuse to escape jobs, but sometimes when we allocate more time to supervise our students, to help our students, we cannot do so effectively when we have so much workload. So this is something that school administrator can consider. School administrator have to give recognition. In the second case study that I've shown you earlier, the PK, the senior assistant of the school actually entered the class during the showcase on the final day of the project. So the senior assistant went in, and a few other teachers came into the lab, and then the students showcased their projects, and teachers feel proud, feel that their effort is being recognized by school admin. So the role of school admin is very, very important. So these are some of the highlights that I want to bring to you from our experience in helping teachers to get started on STEM projects. So a few points that I like to highlight here about the importance of reducing teacher voice and increasing student voice is this. The authority and power of a teacher serve to restrict and dominate the pupil rather than emancipate the student. Emancipate means to give student the freedom, the liberty. So the more teacher want to show off, to know that they know best, to know that they're in charge, we are actually restricting and dominating our pupil. Our pupil will not get a chance to speak their mind. They won't even have a chance to have a small talk with their friends, in the group, because they are. I mean, sometimes we control class too rigidly. We don't allow noise and all that kind of things. Everything must follow rigidly on the procedure, right? So this may not be good, all right? And the second point here is an authoritative manner that promotes the image of teacher as keeper of certain knowledge, and an authoritarian teaching style would both deny pupils any feeling of personal responsibility as to what they learn and how they learn it. So when we emphasize on our voice in science lesson, the students don't have a personal ownership of the lesson. But when you let them have their voice, let them decide how they want to do things in their favorite way, in the way they like best, they feel that they own the learning. They have personal responsibility on what they learn, and that would change their motivation, and that would change the effort they put in for our subject in STEM. Don't worry about. Personally, I would always tell teachers, don't worry about not being able to finish the syllabus, because if you are able to get them excited about science, about mathematics, about STEM subjects, the studying will come on their part. All right, the study will come on their part because they have this intrinsic motivation. All right, so don't worry about exam too much. So the conclusion that I like to share with you here, this is my second last slide, is that the value of student voice lies in their involvement in personal discovery. When they do projects, when they do experiment, when they do practicals in science, it is about personal discovery. It's not so much about completing a report, a lab report, and they got the formula calculated right and all that. It's about personal discovery. Number two is about learning of the scientific method. We want to teach our students to investigate in a systematic way. All right, we want to empower them, to tell them that it is okay for them to redesign, to devise different way of doing things. We also want their voice in developing a sense of curiosity. We want them to feel free to ask questions, encourage them to ask questions. We want their curiosity to be spoken. All right. And number four, to acquire confidence in devising strategies from problem solving. I think this is very obvious in the cases that we have seen earlier, and also in the presentation by the previous speakers. And also to learn social cooperation through group work. All right. Student voice also is about them talking with themselves. It's also about their voice talking to other people, and also about their voice talking with their friends or to the teachers in the class. So we must always give opportunity for students to speak. All right, we want to hear what they have to say about this or that. Okay, and this is my last slide. Again, I like to emphasize that if you want to have student voice increase, we must reduce teachers' voice. We must have less control. All right, we may set the boundary, Or sometimes we might want to loosen the boundary a little bit and let the student explore. We want to highlight, we want to give student voice its rightful place in science education. So with that, I stop here. Thank you so much.
All right, thank you, Dr. Chin, for transferring the knowledge to all of us. Okay, it is really an interesting topic for us to ponder how to raise the student voice in science education. And Dr. Chin has actually alerting us as an educator that teacher is supposed to be the facilitator, yeah, to guide the students along the side and not the sage on the stage. Okay, so I hope everybody enjoyed Dr. Chin's valuable sharing. So once again, thank you, Dr. Chin, for your contribution. Right, now the next presenter that we are pleased to invite is Cikgu Yasmin Nurul Amin, Cikgu Yasmin Nurul Amin, and she is Guru Cemerlang Kimia from Sekolah Menengah Kebangsaan SMK Lasale, Petaling Jaya, Selangor. And she's going to share with us a title called Cozy Lester Race. Okay, so without further ado, let us put our hand together again on the air to welcome Cikgu Yasmin. Thank you.
Okay, hi, hello everyone. Okay, I'm Cikgu Yasmin Nurul Amin from SMK Lasal, Petaling Jaya, Malaysia. So I'm gonna share my screen now so you can see what I'm about to talk about today. Yeah.
Hello, Cikgu Yasmin.
Yeah. Okay. So, yeah. Okay. So can you see my screen now? Yeah.
Yeah.
Okay.
Yeah.
All right.
I think just now I'm too excited. I forgot to call for a Q&A session for Dr. Chin. So
Okay,
maybe participants.
You want to do that first? It's fine with me. Yeah.
It's okay. So we'll let Cikgu Yasmin to carry on. So for the participants, if you have any questions to pose to Dr. Chin, you can hold your questions until after Cikgu Yasmin. Yeah, thank you.
Okay. This is my topic for today. Basically, it's mastering the topic of carbon compound. It's a topic in chemistry, and it's through the activity of carboxylusterase among the Form 5 Science Stream students in Lasal Petaling Jaya Secondary School, Malaysia. So a little bit about me. So I have a degree in applied science, majoring in industrial chemistry, and I worked as an analytical engineer before I became a chemistry teacher. So I've been teaching chemistry, science, and life stories to my boys in SMK Lasal Petaling Jaya since 2005, and I've been appointed as an excellent teacher back in 2 years. And these are some of the awards that I received. So I'm the first school teacher nominated as top 50 finalist of the Global Teacher Prize in Malaysia and Southeast Asia. And I've been recently chosen to represent Malaysia as a teacher chaperone for NASA Space Camp in Houston. But unfortunately, because of the COVID-19 outbreak, so the NASA Space Camp has been postponed to July 2021. Okay, so basically for chemistry, when students first entered my class, they are always intrigued by the fact that we have so many formulas to memorize. Okay, there's a lot of setback in memorizing chemical formula, and that makes them so afraid. And especially in the current setup of the IR 4.0, chemistry has been assumed to be difficult because many students nowadays, they don't really like memorizing, and to them it's difficult and time consuming. So with artificial intelligence and Internet of Things approach on the rise, the need to memorize, the need to study chemistry is like declining, because memorizing has been like an old age method that has been planted in the young minds. I mean, all of us, have been trained and taught by memorizing, and formula after formula, endless chemical equations, and different formula needed to solve stoichiometric problems. Yeah. So basically, in this topic of carbon compound, I incorporated what I love from the beginning of my life, because from a young age, I've always loved taking parts in explorations and treasure hunts. Okay, so it was a form of escapism for me, as I got to solve clues after clues, and basically before I head to my goals. So I thought of, what if I do my topic, carbon compound in a form of phrase. Okay, because the reason I do this is because chemistry is the topic of carbon compound is so lengthy. Normally we take about 9 weeks to finish it, and I felt that my boys are declining in their concentration. So I need a fast-paced, fun-based learning activity. So my main goal is to reduce the timing from 9 weeks to 2 weeks in order to capture my students' attention. It's not easy to study a topic of organic chemistry where it's from alkane right up to ester plus rubber, and it's so time consuming. Okay, so I've chosen like 5 subtopics for this purpose, and I name it carboxylesterase because C represents carbon, as in carbon compound, the topic, and it's also to represent subtopic alkene and isomerism because there's a lot of carbon involved. And then CO also represents alcohol. I take the middle part of the word alcohol. And then Zyl, XYL, represents carboxylic acid, and ester represents ester, the topic of ester. Okay, and before I continue further, this particular carboxylesterase has been also chosen by the Malaysia Palm Oil Council in the Love My Palm Oil campaign since 2017 to be incorporated in their program, in the outreach program for schools. So my activity, I've been like their main trainer for the past 3 years, and my main activity, as in this race, has been incorporated in this Share a Sawit Moment program. So I've been, touch base with teachers almost all of the states in Peninsula Malaysia except for Kelantan and Terengganu, and we haven't gone to Sabah and Sarawak yet. So that will be happening next year, I hope. Okay, and this particular race, I've actually modified it to suit the need of the Love My Palm Oil campaign, and it has been widely spread and widely accepted and loved. That's the most important, right? By the teachers of science and chemistry all across Malaysia, and many of them have also started to do a similar race in their school. Okay. So what did I do? I was a former engineer, and I also love playing games, and I made 6 stations with 2 substations each, and each of the substation, I call it a starter game station and a carboxylester station. Okay, so for the 6 stations, basically you can see here that the stations have one game activity, and then another one is the carboxylester station. So I combine game and chemistry related activity. So I have blindfold with isomerism, magic carpet with carboxylic acid, separate me alcohol, bubbles and ester, ask me alkenes, and coding with fats and oil. So before I started, okay, when I did with the Malaysia Palm Oil Council, many of the teachers asked, why do you even need to have a game station which is not related to chemistry at all? But I was like, okay, you have to play first to understand. Okay, all right. So these are the activities. So in the Ask Me, okay, you can see that I truly chose activities that are not related to chemistry, like totally not related to chemistry. It's just a game station. So in Ask Me, students are given like 4 envelopes, and they were given they are encouraged to ask questions to guess the name of the items in the envelope, but they can only ask questions where the station masters can answer in terms of yes or no. Okay, and then after that, when they finally guess the answer, they can proceed to the next station. And then I have alkenes, where students are asked to complete a flowchart, okay, of the reactions based on a puzzle. And the second station is blindfold. So blindfold, where students are blindfolded. You can see later I have like examples of it. Okay, I recorded a session Okay, so the students are blindfolded and they are required to pick matching information on the usage of rubber materials from the floor. So the blindfolded student will be guided by their teammates. Okay, for isomerism, students are asked to create isomers of alkanes and alkenes. So you can see later as well. Okay, the other 4 stations are basically a separate me, where students are given multicolored stones and they have to separate it according to the colors. And I've also included a small maths activities in it. For alcohol, they carry out experiment of dehydration of ethanol. So basically, they do carry out experiments in the activities according to the station. Okay, and then we have magic carpet, where students are asked to step on a used banner and then they have to turn it over without any of the group members leaving the used banner. In the carboxylic acid station, they have to carry out a simple experiment of oxidation of ethanol. Okay, and then in station number 5, bubbles, students are given a task to choose between 3 different ways to produce bubbles from soap. So they have to blow the bubbles, okay, and transfer it to the friends. So there are multiple tasks according to it. And ester, they have to carry a simple esterification reaction. And finally, break the code. My students are given code breakers to solve, and they have to carry out a task related to saturated and unsaturated fats. Okay, so this is one of it. Okay, so carboxylesterase coding. It's not coding as in like, coding, the current coding where you use in computers, but it's I learned this when I always entered, when I was younger. I'm still young now, but when I was younger, okay, I entered competitions as in exploraces. So this is using the army code. So like 9 Kilo India 5 Oscar Charlie Alpha 5 Oscar Romeo India Echo Sierra. Okay, so this is basically 9 kilocalories, if you can guess. Okay, and like this one, okay, it's also from solving. Basically, a teacher needs to have a high level of vocabulary, because I read a lot, and I love to use this, antonyms and synonyms in making my codes. So Victory Alpha India is Vi. Okay, it sounds like VAI, so it sounds Vi. Deuter minus dew, so it becomes ter. So like Viter. Cikgu Yasmin's nickname, that's me. Okay, Min. My nickname is Min. So it's like vitamin. And then Rasa Sayang A. So this is like a folklore song in Malaysia. Rasa Sayang A, Rasa Sayang Sayang A. So it sounds like A. So this is how I introduce vitamin A, okay, for the subtopic. So this is one way. And when I did this with the Malaysia Palmer Council, the teachers felt that this particular station is difficult, but actually my students can do it in very, very short time, because they are used to solving and creating codings, yeah. Okay. This is Ask Me. I've explained it just now. Okay, this is the blindfold activity. So I'll play this video for you. I hope you can see it.
When is Jeremy going to finish?
Okay, that's my voice. Sorry for that.
What is it? What are you doing now? Finish it, right? Oi, dah ke belum? How he know in front? Just say 2 steps in front, 2 steps. Must say like that. Give instructions, so don't know. Why Raflis is outside? Bagi dia masuk. Oh, perlu tak ada lagi. Okay. Butalan kau sekejap. Ha? Nama. You just... Come on, Jeremy. Cannot walk like that. Come on, Jeremy.
Okay, so you can see that the students are walking, okay, and they are only listening to the sounds of their friends, okay, from the outside of the perimeter. So this particular activity is an eye-opener to me, not only because it's about, a person being blind, but it's about giving instructions, okay. And this, really touched my heart. This particular activity really touched my heart, because I was thinking that, okay, you can see here, if I
You're right.
Okay. Now tilt the body a bit to the right. Okay. Okay. Sama. Benar tu. I'm taking video. Slowly.
oops, okay. Sorry for that. Hang on. Okay. Okay, so this particular activity showed me that, okay, when you give instructions, okay, especially in this activity, when my other students are giving instruction to the one who's blindfolded, you see the words that they were using, some more, move to your left, move to your right, move front. You know, the instructions are not clear. And you can see that the student cannot move because he doesn't understand. And there's too many instructions at the same time. So it gives me a reflection on how we are as teachers, because when we are giving instruction, especially for technical subject like chemistry, how we talk in a language that we understand, but sometimes we don't realize that the language, or you know, the colloquial form that we are using is not the particular words that our students understand. So then sometimes it gives us frustration, because as teachers we thought that, okay, I've taught this, and when the students keep coming and asking, I don't understand, teacher, and you'll be like, I've taught you this, I've taught you before. So you know, this particular activity taught me or made me realize that you have to refine the way you speak to your students, okay, in a language that they do understand, and it's not in the language that you understand. So it really gave me an eye opener on how I speak to my students, the words that I use, how do I refine it until my students understood what I'm trying to impart to them. Okay, I'll show you another video, which is also another eye opener. Oh no, not a video, sorry. Okay, this actually a picture of this student Mohan, okay, the one in red. He was trying to move, okay, but he couldn't move because this particular student, the one in purple, is speaking in Malay language, okay, and the one in yellow is speaking in English, all right, but he is an Indian student, okay, and his mother tongue is Tamil. So he was confused, okay, blindfolded, and it's not easy, because you're listening, and it's not easy when you close your eyes to listen to this. When one student speaking Malay, one student speaking English, and he got confused because his mother tongue, his first language, is not Malay or English. And in came this my superhero boy, okay, in this blue attire, and he just spoke in Tamil, and straight away Mohan could move. See, he was smiling, okay, because he was actually responding to this person. It also gives me another insight that when we teach our students, is it in a language that our student understand? Is it a language that our student can grab easily? Okay, and are we, you know, like on a pedestal where we are just teaching for the sake of teaching? We don't care what words we are using to our students. So, you know, wordings are really important because that's our main form of instruction, medium of instruction to our students. Okay, so basically doing this activity is not just to settle. I get like 2 in 1. I settle my subtopic in 2 weeks, and I also got a really huge insight. Okay, and this is the magic carpet. Okay, and on top here is the isomerism. And this is how the students are using. This is my module. Yeah, so the students are using this activity to build isomers. Okay, so we get to our findings. So my students, before I explain to them about the stations, okay, you can see that the game stations, they don't understand the relevancy of it. It's like my questionnaires is very simple, like, do you know why this station, you know, is part of chemistry? And they don't. So a few of them, like, maybe they pretend to understand, I don't know. But for the chemistry stations, okay, for the Coxy-Leicester stations, yeah, they understood the relevancy, okay, after doing. But after I explain, okay, then only they understood, all right? And students feeling after completing the study games. So basically they feel fresh, happy, because they're boys, okay? They love to play around, and they can't really sit still and just listen to lectures, okay? And after that, I did 2 basically like tests to them, a pre-test and post-test. So the post-test showed that the number of students obtained between 90 to 100, okay, is around 20 students. Yeah, this is a total of 56 students. So no one is in the category of below 50. So my conclusion, okay, because the first day I took about 2 hours and a half to complete the explorers, and then followed by another 2 weeks of strengthening the information, and finally the post test. So there's an increase in efficiency because the learning and teaching has been reduced significantly from 9 weeks to 2 weeks, and within the next 2 weeks, the students remember because they were doing the experiments. And normally when I do the experiments in class, if there's no objective, there's no race. If it's not a race, the students will just take their time to do the experiments, and they were dilly-dallying here and there. But because it's a race, they could complete the same experiments in like less than 10 minutes, especially for the oxidation of ethanol and also the esterification. Because normally they'll just take their own sweet time, and it will go more than 30 to 45 minutes, okay? Because they just felt like, okay, we want to waste some time. So by doing this, they become more diligent. So in future, I would love to have more Coxilester race mini game station for my other topics, and I'm working on it. So working on this during this era of pandemic. So this year I wasn't able to carry out this Coxilester race, but I'm developing online race, okay, a similar online race with my ex-students who has been in this game session before, so that it can be used for my next classroom activity, but online, because now we can't really do all these activities without touching each other. We have to maintain social distancing and all. So yeah, these are my students. Okay, they have graduated. These are the first batch who has done the race. Okay, so yeah, that's the basically end of my discussion. So yeah, you feel free to ask me about it.
All right, thank you, Cikgu Yasmin.
Yeah.
So we open to the floor Q&A. All right, so we have 10 minutes Q&A session here. So we are going to divide 5 minutes for Dr. Chin and 5 minutes for Cikgu Yasmin. Okay, participants, come on. You have any questions? Yeah, I think Cikgu Yasmin. A question for Dr. Chin. So Dr. Chin, you are wanted. Okay, thank you.
Yeah. Right. Yeah, this is the usual concern whenever we do project-based learning, STEM project, or time is always a concern. In fact, when we do this with the school teachers, all right, combining science and maths lessons and all that, it really consumes time. So one way to, but it depends on your students. One way to solve this problem is to allow your students to have their own group meeting, right? But then with the current COVID and all that, there will be other different concerns. But my personal belief is always the quality of the learning process is more important than the quantity of the curriculum being delivered to them, right? So the quality is more important than the quantity, right? Thank you.
Okay, Dr. Chin, I think Dr. Kong also posed you a question. Please kindly provide feedback. Thank you.
This question is for me. Okay. All right. I think one way to help our students is to help them, because chemical formula we are using symbols. One way to help students is to explain to them the name behind this formula, the name behind the symbol. All right. For example, Ca is calcium. Cr is chromium and all that. So we need to explain to them the full name of the symbol or the formula that we use. I think that's very important. And secondly, because it's involved memorization, I think game would be a good strategy, because when they play game, All right, they learn to memorize in a fun way, so it is less taxing. It is not like they are looking at the formula and memorize blindly. So we can put it in a form of games. Thank you.
Okay, thank you, Dr. Chin. I think the following question is posted to Puan Yasmin.
Okay. Yeah. Okay. The students are provided with procedures when they are involved in experiment activities because they have never done the discussion on the activities before. Nothing. So it's just based on the activities during the explorers, but they were not given. They couldn't take their textbook. They just had their module, which is the module I prepared for them. So in the module, they have the experimental procedure. So they just follow the one in the experimental procedure. So it's like their first time of seeing this, because I'm sure even though if they go to tuition centers to learn the topics beforehand, they cannot conduct activities, experimental activities in the tuition centers. So, they still rely on us in school. So yeah, that's one way of doing it. Back to you.
Okay, thank you, Puan Yasmin.
Mhm.
I think we have one question from Puan Savini.
Oh yeah, okay. Yeah, you're welcome. Savani Sararak. Okay. Yes, you can actually conduct exploration and treasure hunt, but I think in this era of the pandemic, some of the activities we need to really consider because they involve like running around. But I felt that we shouldn't deprive our students of healthy activities of moving about. It's just that um, they have to take care of their social distancing, physical distancing. Yeah. And yeah, okay, you can contact me for the explorers, for the how I conduct the stations. You can email me. Yeah.
Okay, thank you, Puan Savini, for the questions. Any more questions from the floor? Okay, thank you. All right, any more questions? Calling once? Calling twice? And calling off. All right, so guys, do you have any questions for Dr. Chin as well? Okay, thank you, Shamala. Calling once for Dr. Chin. Calling twice for Dr. Chin. Calling off for Dr. Chin. Oh, okay. Dr. Chin, you have one question. Dr. Chin, can you provide your feedback?
Yeah, I think that was more like a feedback. It's not really a question. Yeah, so that's why I said the school administrator, the role of school admin is very important. When the school admin see school teachers pouring in extra time and effort for science projects, or maths projects or whatever it is important that the school administrator take the initiative, all right, to reduce at least some workload from the teachers so that they can dedicate their time and for student project. All right, and I was very fortunate when I was teaching in Sabah. My senior assistant actually saw that I was having problem juggling with time, and he offered to reduce the number of classes I want to teach. But anyway, if we have school admin that do not take such initiative, it is okay for us teachers, all right, to approach our school admin to tell them that we are committed to some certain projects, and then we ask if the school admin will be kind enough to relieve us from some of our workload. All right, so we can speak up for ourselves. All right, we have to make our voice heard as well sometimes. Thank you.
Okay, thank you. Any more questions from the floor? On the air, you may post your questions, right? Thank you, Dr. Kong. All right, so okay, so if no questions, thank you, Dr. Chin and Cikgu Yasmin for the inspiring sharing. Okay, I believe that the educators that joined us today, they learned a lot. Okay, so the next presenter that we are pleased to invite is Dr. Firman, the physics education lecturer from University of Negeri Jakarta. He's an international speaker of today, right? Dr. Firman is from Department of Physics Education, and he is going to share with us the simulation for STEM learning. So let us welcome Dr. Firman. Okay, so Dr. Firman, please.
Okay, thank you. Can you hear me? Bisa mendengar suara saya?
Ya, boleh didengar.
Okay.
Okay.
Okay. Thank you. I share. Okay. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Halo.
Ya, Dr. Firman, we can hear you. Dipersilakan.
Okay, yeah. Thank you, Miss. In this morning, I want to the presentation Bengkel Perkongsian Amalan. The title is Bengkel Perkongsian Amalan Terbaik Guru STEM 2020. My name is Firmanul Catur Wibowo. I come from Department of Physics Education, Universitas Negeri Jakarta, Indonesia. Okay. This is my profile. Okay, this is my profile. This is my research, focus research in basic education, STEM with simulation. Okay. I like the Penang destination. Okay, Penang destination. And then my address Serang City, Banten, Indonesia. This is my email fcwibowo@ong.ac.id. My personal web www.firmanulcwibowo.com. And then presentation in this morning. This is planned in my blog. This is ID Scientific. Okay. And then okay. Before the presenting, I want to my video from STEM activity.
Hello everyone, we are going to identify STEM education learning process. Before we start our explain, do you know about STEM? Okay, well, STEM means science, technology, engineering, and mathematics. They learn the science process. One of them writes a material, sketch, and the step to make a kite. In this case, it's very important, right? We know that there is a science process. When they write something, it can make great memorable in their brain. They learn technology process. They make a tool to detect the sound for a kite when it flies so high. They learn engineering process. They cut the bamboo. After see the sketch, they start contractions of the kite. They learn mathematics process. After the prototype finish, they can find many shapes like triangle, circle, and square. Except above, including mathematic area, right? Hi everybody, did you get the point on my video? Can you mention the learning engineering area, right? Hi everybody, did you get the point on my video? Can you mention the benefits STEM education? Hello everyone, we are going to identify STEM education learning process. Before we start our explain, you know about STEM? Okay, well, STEM means science, technology, engineering, and mathematics. They learn the science process. One of them writes a material, sketch, and the step to make a kite. In this case, it's very important, right? We know that there is a science process. When they write something, it can make it memorable in their brain. They learn technology process. They make a tool to detect the sound for a kite when it flies so high. They learn engineering process. They cut the bamboo. After see the sketch, they start contractions of the kite. They learn mathematics process. After the prototype finish, they can find many shapes like triangle, circle, and square. Except above, including mathematic area, right? Hi everybody, did you get the point on my video? Can you mention the benefits STEM education? In my point of view, STEM education system very important and meaningful because it can build creativity, critical thinking, and problem solving to the student. I suggest you, the teacher or lecturer, to developing the STEM education system to implement in your education. That's all. Thanks for watching.
Okay. The video, the phenomena of STEM. Okay. Science, the explain, the discover, and describe a better understanding of life. What what is technology, invent and innovation to the purpose improving the natural world, and then engineer to use control, modify or design material, process and system. The what of engineer, what could be, and then mathematics, symbolic language for representing reality. The keyword make sense of the word with number. Okay, and then the framework, the project-based learning in STEM. The project from the bamboos, the student. Number one is relating chemistry concept with STEM principles. Planning the project when integrating the concept with STEM. And third step, developing the STEM project. And then step cooperating, working, collaborating in STEM project. And the last last task, transferring STEM project representation. Okay, and then table integration in chemistry lesson with example of goldfish aquarium project. The STEM project is goldfish aquarium project. And then core of science, the concept of acid and base, technology, aeration technology, engineer create aquarium, art, decorate the aquarium according creativity and the student, mathematics calculate in the aquarium products. And then testing of indicator again, acid and basic solution using pH meter. And then establish natural indicator, add display PowerPoint as presentation material. And then mathematics activity calculate in the manufacturing of solution with a certain pH. And then science of the testing, the endurance of living things. Technology using laptop, mobile phone, projector, PowerPoint, and media presentation material. Engineer assembling to aerosol, make a creativity pH measure. And then from the picture, student developing the critical skill. Ini activity student in the class, and then this product is goldfish aquarium project. Ladies and gentlemen, I want to explain to you the four pillar of STEM. STEM is an approach to teach that large and then constituent part, and then STEM removes the traditional barrier erected between the four disciplines by integrating the four subjects into one cohesive curriculum. So, current state of the STEM. Number one, many students not receiving an adequate STEM education, and then focusing often on specially or magnetic high school, and then STEM subject not totally every day. Okay. Actually, preparation for life. STEM preparation student for life. STEM preparation student for life because regardless of the professional they chose to follow, STEM teacher student how to think critically and how to solve problem and skill that can be used talk out loud. Okay, the critical part of STEM. Number one, improved STEM program can create individual capable of new solution and better decision. Increase science and math capability is not enough because in experiences centered on design, innovation, engineering, and technology, increase creativity, inventiveness, ingenuity, and imagination capabilities. This characteristic from fourth person in STEM center. Okay, the preparing the next generation to success life is a tall order. In generasi Z ini diharapkan bisa menyusun STEM itu berdasarkan kearifan lokal atau local wisdom, and we will substantially fail if we don't teach child how to think critically. STEM melatihkan untuk berpikir kritikal and problem solver. In their car from school, empathy solving problem correctly, not creativity. Creativity is very important in 20-year skill because the digital skill and else. Target reward, logical thinker, factual, competency in math and science skill. Okay, my focus from this research is STEM in simulation. In this simulation, STEM 4.0, 1.0, 3.0, 2.0, 1.0. We recognize that STEM might be seen as a rank of integration and application. Number one, a science class without of the other STEM component may be seen as STEM, and fully integrated science class with all STEM. How do qualify our program? Okay, the NSTA, The case from STEM education, Roger Webben, my reference from the STEM research and application. Okay, and then the basic STEM 1.0 for disciplines and operational independently. STEM discipline, science, technology, engineer, and math. Okay, STEM 2.0. Okay, science and technology discipline, science and math, technology and engineer, technology and math, engineer and math. STEM discipline 3.0. Okay, science, technology, engineer, science, technology, math, science, engineer, math, math, technology, and science. And then STEM discipline 4.0, integrating. Okay, the what keyword integrating science, technology, engineer, and math. Okay, in this morning, I want to explain to you the integrating science, technology, engineer, math with simulation. Okay, the example STEM 2.0. Okay, integrate into discipline. A science class use computer to research a problem and develop a presenting. A science lesson utilities embed algebra standard to teach a lesson. Jadi 2.0 ini melatihkan siswa hanya menggabungkan dua disiplin. Oke. 3.0 adalah menggabungkan 3 disiplin, science, technology, engineer. Oke. Dan STEM 4.0 adalah menggabungkan keempatnya, integrating science, technology, engineer, math. STEM discipline 4.0. And then assign class examine data using statistic. Okay, the mathematics, the tools is statistic, then use computer to research problem develop. Okay, in this I to watching to you the animation. Okay, animation in this STEM simulation, the from for teaching engineer construction a scale version a satellite comparison model and model based on project evaluation. Okay, I use from your handphone or computer. Can you see my URL https://gop.id. Okay, and then you can see my simulation. My simulation included from the STEM. In STEM, integrating itu teknologi online and satellite development. Jadi watching animation ini from the construction, reconstruction concession in first step from STEM. Okay, I want to watch my simulation. Okay, okay.
Dr. Firman, you are sharing something?
Yeah. Okay. Okay. Wait me. Okay. Ladies and gentlemen, and then you can open from the URL. Okay. Kita copy. Okay. And then new. Okay. New tabs. Paste. Okay, and then you okay. Okay, I'm sorry.
You need to reshare the screen.
Okay, I'm sorry. I choose. Sebentar, saya cari dulu. Belum mana ini? Ya.
You click share screen and then
Jendela. Iya.
all the screen. Top one. Yeah.
Oh. Okay. Simulation. Okay. I'm sorry. The simulation. It is few trouble. Okay. And then simulation for a perception stamp. This simulation. You are open in the my hosting domain goop.id, and then from the game GOOP, the acronym of Game Open Online Basic Instructional, and then the step from this class simulation for a perception stamp, and then you look the child from the simulation, and then step from PPL stamp in action. My student create one product from the perception in simulation, and then this is product. Okay. and then product implementation STEM. Okay. Wait me. I want to watching to you the visualization simulation. Okay. Wait me. Okay. Okay, I'm sorry. This is trouble my computer. Okay. My focus research is from STEM simulation. The STEM simulation you can create my domain goop.e.id. Your GOP acronym of Game Open Basic Instructional. The simulation ini from the means of the perception from the beginner STEM introduction. You are seeking from my simulation. You are right. FESEKI. Okay. The password 123. Password 123. Okay. 123. You are click login. Okay. Okay. This is in Indonesian language kompetensi IT atau CPL atau capaian pembelajaran lulusan kompetensi dasar. This is indikator menjelaskan proses perpindahan kalor konduksi, ini konduksi, konveksi, and radiation, and analysis karakteristik heat transfer, okay, and then focuses from the simulation in STEM is my game. Okay, this permanent or game misi 1. Okay. Hello, my name is Andy. Can you from the heat transfer conduction? Click play. Okay. This is from ferret. And you can Bunsen. Okay. Tampilkan from the benefit the simulation, microscopic simulation. Okay. This is from the benefit the simulation is microscopic. Okay, the microscopic simulation. Okay, you can play in Indonesian language mulai. Okay, and then the microscopic ini from the move, and then from the works from the solid from the ferret ini. Okay, you are repeat again. Okay, and then the simulation in this time from this five step from the perception. Okay, and then konduksi itu. Okay, this is aluminium and ferrit. Okay, atau tembaga. Okay, you are the thermometer, okay, and then you click the microscopic, okay, and then you click apply atau mulai, okay. Okay, and then you are finished from the game. This is game, and then from the evaluation. Okay, okay. You are the my from the question. This is question from the case in the simulation. Okay, from the case the simulation. Okay, and then you choose from the question and answer. He and I. Question and answer. You are I, B, C, D, or E. Okay, okay, okay. You are file and then repeat again. Okay, okay, okay. Missy one. Okay, apply. Okay, mulai. Okay, konduksi itu apply. Okay. Okay, okay, and then okay, finish. Okay, misalkan okay, kira okay, and then the simulation from the student is from the cognitive skill and collaborative skill from the question and answer. Oke, misalkan jawabannya oke. Ternyata jawabannya B. Oke. From the next, okay. You are finished and then the misi 2. Okay. Okay, misi 2. Okay. You akan klik play. Okay, and then okay. This is microscopic. Okay, tampilkan mikroskopik. Okay, you apply. Okay, okay, you are the click finish. Okay, okay. This is question and answer. Okay. You are file from the next from the first okay, and then okay, okay,
Dr. Firman?
okay, 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 the finish from the presentation, the conclusion, the stem is okay. Okay, the STEM education is a international. Okay, STEM education is the international integration of science, technology, engineer, and mathematics and their associate practice to create a student-centered learning environment in which students investigate and engineer solutions and to problem and construct evidence-based explanation of real-world phenomena with a focus on student social, emotional, physical, and academic need to share contribution of school, families, and communities partner. Oke, thank you. Berprestasi bukan segala-galanya, tapi semula bermula dari prestasi. I'm sorry from the trouble in my computer when you're watching my simulation GOOP. Okay, thank you. Terima kasih, sukses untuk semua. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, terima kasih Dr. Firman. It is very interesting on your video. I think the floor asked you how to grade this game. They are very interested. So So Dr. Firman, would you like to share with the floor on how you create the video? It is so interesting.
Okay. Can you share how to create the game? Okay. Okay, the login code. Okay. Okay, thank you for your question. My video, this is okay. The hosting and domain glp.id. You can the keyword, the username Fisika, FISEKI, and your password 123. Okay. Okay. Create the game. Okay, create the game. The game is the platform is Flash Simulation. And then okay, user Fisika and password 123. Okay. And then you will create the simulation, the platform the choose Flash Macromedia Flash Simulation, and then JavaScript, and then else. Okay. Any question, Miss?
Yeah, I think no questions. I believe that Associate Professor Dr. Azida Abuzidan from USM Penang has shared the link with the audience as well. So thank you, Dr. Firman.
Okay, thank you too, Miss.
Thank you. It is a very interesting movie and interesting games. Thank you for your sharing and thank you for your contribution. All right, thank you. So the next presenter that we would like to invite is Cikgu Wanu Ayu, Cikgu Wanu Rahayu, or also known as Cikgu Ayu, and she is the Guru Cemerlang, Guru Cemerlang from the Guru Biology from SMK Section 5, Wangsa Wangsa Maju, right? And Cikgu Ayu would like to speak in Bahasa Malaysia. Yeah, so Cikgu Ayu dipersilakan. Thank you. I think Cikgu Ayu, can you on your mic? We can't hear you.
Okay, sorry. Assalamualaikum. Okay, before that, I'm not a Guru Cemerlang. I just an ordinary biology teacher. Okay, so I will show you my presentation. So before that, okay, I would like to proceed my talk in Bahasa Melayu. Okay. Okay, nama saya Wan Nur Rahayu binti Muhammad Yunus dan saya mengajar dekat SMK Section 5 Wangsa Maju. Okay, kalau tengok kat sini, yes, I love nature. Saya suka. Okay, kalau kat sini anda akan nampak I love biology, and ini yang saya terapkan dekat pelajar-pelajar biologi saya. Okay, di mana ini untuk menarik minat pelajar sebab kebanyakan sekarang pelajar memang tak minat ataupun dia takut dengan especially for the science elective. Okay, mereka mungkin rasa banyak fakta yang perlu dihafal and ini juga mempengaruhi minat dan sebagainya. Okay, alasan yang banyak dihafal. Jadi I love biology ini saya terapkan dan supaya selalu disebut pelajar secara tak langsung dia akan minat subjek ini. Another one, kena minat dan sayang cikgu. Alright, so apabila kita suka, kita akan minat, insyaAllah ilmu mudah untuk diterima dan lebih difahami. So, semasa PDPC, saya akan terapkan juga teknik pembelajaran iaitu IBSE dan juga model pembelajaran 5E supaya murid lebih mudah faham dengan topik-topik yang sukar. And also for sure fun learning is also applied. Okay, mari kita lihat dulu apa itu IBSE dan juga model pembelajaran 5E. Okay, IBSE, Inquiry Based Science Education, iaitu pendidikan sains berasaskan inquiry, dan saya menekankan pada pendekatan inquiry. Okay, apa itu pendekatan inquiry? Iaitu pembelajaran iaitu melalui pengalaman. Inquiry ini bermaksud mencari maklumat, menyoal dan menyiasat suatu fenomena yang berlaku di sekeliling. Okay. Pembelajaran secara penemuan inquiry ini berlaku apabila konsep dan prinsip utama dikaji dan juga ditemui oleh murid sendiri. Okey. Sekejap. Okey. Murid sendiri, murid akan melalui aktiviti seperti eksperimen. Ya, saya banyak buat eksperimen dengan pelajar supaya pelajar dapat menyiasat dan buat sendiri kesimpulan yang mereka dapat berdasarkan eksperimen yang telah dijalankan. Okey, untuk ciri-ciri IBSE iaitu menyiasat, kita teroka iaitu kita explore, kita membuat kesimpulan, kita berkomunikasi, which mean berkomunikasi dengan pelajar-pelajar dan guru yang lain. Okey, IBSE menurut Word dan Kelty, IBSE menekankan murid memahami perkara yang dipelajari dan bukan setakat menghafal konten sahaja dan maklumat. Okey, kefahaman dan kemampuan pelajar memperolehi pengetahuan dan kemahiran berpunca dari inquiry. Okey, baiklah. Untuk model pembelajaran 5E, yang ini juga saya terapkan dalam semasa PDPC supaya kita dapat libatkan pelajar-pelajar dalam aktiviti, kita dapat libatkan pelajar-pelajar dalam aktiviti kelas, PDPC dan sebagainya supaya mereka pelajar ni dah dapat dia dapat cari sendiri apa informasi dan ilmu yang diperlukan. Okey, first kita engagekan budak, kita libatkan. Ini adalah set induksi selalunya. Okey, untuk kita teroka selalunya untuk eksperimen. So kalau macam saya macam Cikgu Bayu, Cikgu Sains, kita akan buat banyak eksperimen untuk supaya pelajar ni dia lebih mudah faham, dia mudah tengok, okey ini adalah eksperimen, okey ini kesan dia. Okey, kemudian selepas kita explore, budak explore, cikgu berperanan untuk menerangkan, kita terangkan kat pelajar, okey kenapa sebegini, kenapa otot ini bergerak sebegini. Okay, kita kena explore, kita kena explain dekat budak, kita kena terangkan kesemuanya. Kalau tidak nanti pelajar kita akan dia akan takut tersalah konsep. Okey, kemudian kita elaborate, kita huraikan. Di sini kita akan tengok sekiranya info yang mereka dapat, info yang mereka terima bercanggah. Okey. And last one adalah untuk evaluate iaitu menilai. Okey, model pembelajaran 5E ni apa dia punya kebaikan dia adalah meningkatkan motivasi belajar kerana pelajar ini terlibat secara aktif dalam proses pembelajaran. Okey, kalau tengok pelajar ini dia akan membantu juga untuk mengembangkan sikap ilmiah pelajar. Okey, model 5E ni memang contoh untuk engage ini selalunya kita buat aktiviti adalah set induksi. Okey, explore yang ni kita boleh buat untuk eksperimen secara individu, berpasangan ataupun berkumpulan. Selalunya kita tengok dan lihat bergantung pada radas ataupun equipment yang diperlukan. Next one adalah penerangan. Untuk penerangan ini selalunya dalam bentuk presentation, pembentangan, projek ataupun menghasilkan model. Next one adalah untuk E yang keempat adalah elaborate, di mana kita kaitkan pengetahuan yang telah ada. Dan last kali E adalah evaluate, di mana kita menilai. Contoh quiz, latihan ataupun ends dengan ujian ya. Next one kita pergi tengok untuk engage, iaitu melibatkan. Di sini adalah tahap pemangkin minat, di mana ini adalah set induksi. Kita nak bagi murid kita idea, curiosity, ingin tahu, dan ini akan kita kaitkan juga dengan pengalaman seharian pelajar. Next one adalah explore, di mana murid akan membina pemahaman konsep berasaskan first hand experience. Dan seterusnya murid akan membina pemahaman berdasarkan daripada idea yang sedia ada. Seterusnya adalah explain. Guru perlu melibatkan murid dalam membuat penerangan dan pembinaan idea. Selanjutnya untuk refleksi. Okey, apa yang murid temui dalam penerokaan dengan menggunakan soalan-soalan. So cikgu dah kena get prepared lah dengan soalan-soalan yang perlu ditanya supaya ini membantu kepada para pelajar untuk memahami dan mendalami apakah konten dan juga hasil eksperimen yang mereka buat. Next one adalah elaborate, mengukuhkan dan mendalami dan mengembangkan pemahaman konsep melalui aplikasi konsep tersebut, dan last sekali adalah evaluate, iaitu menilai. Pentaksiran melalui pelbagai kaedah dan tugasan. Yang ni kita bagi tugasan dekat pelajar. Seperti biasa sometimes kita boleh buat quiz dan sebagainya. Dilakukan untuk menyemak perkembangan pemahaman murid iaitu melalui pentaksiran formatif. Ini adalah saya share gambar semasa PDPC saya. Ya. Contoh eksperimen yang sebab saya ajar bio, so dia melibatkan banyak hands on dengan aktiviti luar kelas and sometimes dekat eksperimen dalam kelas. Saya suka untuk pelajar saya pelajar bandar. Jadi mereka tak biasa dengan contoh haiwan, pegang katak, pegang cacing, geli and so on. So saya tengok ini pelajar perempuan. Pelajar perempuan saya kena gali sendiri. Cari cacing dekat kebun. Kebun sekolah saya, pelajar kebun. So kalau tengok pelajar-pelajar akan ada satu inilah daripada pelajar yang kalau tengok kat sini semua takut-takut kan, semua geli-geli semua. Yang ni pun sama juga. So mereka try cari bagaimana nak cari cacing. So kita akan bagi tahu kat kawasan mana, kawasan lembap, tanah kering atau sebagainya. Dan apa yang ada pada permukaan tanah. Kat situlah ada cacing banyak. So pelajar secara tidak langsung dia akan membantu untuk carilah maksudnya. Ini pun sama juga. So daripada pelajar takut tadi, sekarang pelajar dah mula untuk pelajar dah mula untuk sukakan, dah pegang, berani pegang. Ini pun sama, dah berani pegang. Ini masih takut-takut lagi. So selepas kita mencari cacing, so kita kena explain dekat pelajar. Ini kita yang saya cakap tadi, yang konsep 5E tadi, kita akan explain to the students. Kita terangkan berkenaan dengan otot-otot yang ada pada cacing tersebut. Otot melingkar, otot bujur. So pelajar akan lebih memahami. Ini sebagai contoh. Sepatutnya ada video kat sini. Sekejap ya. Sepatutnya kat sini ada video yang bergerak. Cacing dia bergerak sebenarnya. Tapi dia tak keluar. Is it keluar dekat live?
Tak keluar. Boleh pergi balik kepada video asal lah kot. Ataupun buat dia slideshow balik. Not full screen.
Alright.
Maybe.
Tengok. Dekat sini pelajar akan tanya cikgu pelbagai jenis soalan. Soalan sometimes kita pun tak terfikir. So maksudnya pelajar akan nak tanya, dia ingin tahu apa yang berlaku pada cacing tersebut. Seterusnya katak. Katak. So kita maklum pelajar-pelajar semua memang agak takut pegang katak sebab geli. Jadi bila saya buat begini, ramai pelajar macam, ya Allah cikgu, katak ni cikgu, macam mana ni kan? So kita try, betul tak pelajar boleh pegang? Tengok macam mana bentuk dia. So memang kalau yang first anda tengok gambar ni, memang pelajar geli pegang katak. Nampak gambar ni memang pelajar geli, takut, boleh lari. So ini yang first punya. Okay, kemudian kita tengok katak lompat. Ini actually bukan video video katak melompat. Tapi tak apa, kita tengok video yang lain lah. Okay, ini pelajar sudah mula try nak pegang. Okay, tengok the movement for the frog. Okay, ini pun muka comel. Okay, dah start dah start untuk pegang, rasa, tengok bagaimana katak melompat and pegang tekstur dia sebab kita ajar permukaan dia lembab, dia ada macam mana sistem dia, so kita ajar dia tengok benda-benda ni. Kemudian pelajar dah mula berani pegang, pelajar dah mula berani, so pelajar dah seronok, actually dia dah boleh lawan perasaan takut tu. Ini saya dan ini katak yang mereka pegang kecil je. Sebab saya takut bagi katak besar nanti melompat semua. Ini saya combinekan dua kelas sebab masa tu pelajar-pelajar nak join juga. So saya teruskan. Seterusnya adalah untuk kepak ayam. Yang ni kita banyak ajar pelajar about the tendon, about the ligament, about the muscle, bicep, tricep, antagonistic muscle. So kita banyak ajar fakta, tapi sometimes kita juga perlu buat eksperimen dengan pelajar supaya pelajar lebih memahami dan faham. Contoh this one for the dissecting of the chicken wing. So kita lukis, tunjuk this one sebab pelajar dah belajar apa itu metacarpal, phalanges dan sebagainya. Ini adalah contoh di mana pelajar sendiri akan belah kepak dan cek. Sekejap ya. Belah kepak dan juga dia cek sendiri, dekat mana ligament, dekat mana tendon, dekat mana cartilage yang kita ajar pelajar, ini cartilage, the leg of the cartilage dan sebagainya. Pelajar-pelajar sebab mereka kata, cikgu kami selama ni makan saja. Kami tak pernah buat eksperimen, kami tak pernah buat benda ni. So kita bagi mereka peluang untuk buat. So pelajar-pelajar alhamdulillah suka dan mereka faham dengan benda-benda ni. So selepas kita buat, kita akan selepas kita suruh budak buat, kita akan explain to the student. So ini adalah video actually. So saya akan tunjukkan video. Ini juga gambar. Dan ini kepak.
Bawah ni. Ni lepas. Ni tarik. Bawah.
So pelajar first time tengok kepak dengan antagonistic muscle. Satu tarik, satu mengendur, satu mengecut kan. So ini yang mereka nampak. So bila macam ni, so mereka akan, oh cikgu begini ya cikgu. Ini yang jadi badan kita. Kita punya bicep dan tricep. Terusnya ini pun sama juga. So pelajar seronok tengok benda-benda ni.
Nampak? Cikgu kalau tarik bawah aku
So aktiviti ni sebenarnya menarik perhatian pelajar dan pelajar memang seronok. Kita sebagai cikgu kita perlu menarik lagi perhatian supaya pelajar minat kepada subjek kita. This one untuk tikus, dissecting. So pelajar-pelajar pun cikgu nak belah. Kita belah tapi kita tengok organ-organ dalaman dia. Ini masa saya di SMK Vivekananda, sekolah lama saya. Ini di sekolah baru saya, SMK Section 5 Wangsa Maju. Next one saya juga buat field trip. Field trip dengan pelajar-pelajar saya. Contoh lawatan biologi. Yang ni saya pergi kepada beberapa tempat sebab ada yang untuk paya bakau. Syllabus tingkatan 4. So kita pergi juga kepada paya bakau dan juga tengok haiwan-haiwan sekali. So pelajar memang seronok dengan field trip yang kita buat. Pelajar pun dah pegang-pegang haiwan. So mereka rasa seronok. Ini saya pergi dekat paya bakau. Okey, ini kajian tumbuhan. Okey, kajian tumbuhan. Okey, di sekolah. Okey, so pelajar-pelajar kena check. Okey, kesan-kesan, okey, nutrien pada tumbuhan. Okey, so dia akan tengok. Selalunya kita akan cakap pelajar lelaki tak minat. Okey, tapi bila buat eksperimen atau aktiviti seperti ni, kita nampak pelajar-pelajar lelaki pun bersemangat, okey, untuk membuat aktiviti dalam kelas. Okey, ini sebagai contoh.
Kan udah nyambung Pak Akpin, jurusan bangunan, jadi membangun remun gitu Pak Akpin.
Okey, ini juga okey untuk tanaman. Okey, semasa PKP saya juga membuat meminta pelajar untuk pembuatan jeruk. Okey, so pelajar kena buat jeruk dan hasilnya kena bawa datang sekolah lah selepas itu. Maksudnya mereka buat beberapa hari sebelum masuk sekolah, nanti kan rosak pula ya. Okay, so biologi pembuatan jeruk. Okay, so pelajar-pelajar memang akan try pelbagai jenis. Okay, guna gula, cuka, okay, garam dan macam-macam yang kita pun tak terfikir. Dan memang sedap. Okay, ada yang buat kat sini jeruk cili. Okay, ini dia akan hantar video dekat saya. Okay, contoh cikgu pembikinan jeruk. Okay, so ini video-video yang mereka akan hantar dekat saya. Okay. Proses-proses dia. Okey, ini antaranya. Okey, kemudian juga semasa kelas saya juga minta pelajar hasilkan slide. Okey, memang pelajar seronok dan slide yang dihasilkan kenalah cantik, baru saya akan rasa bangga dengan pelajar-pelajar ni. Contoh ini slide yang dihasilkan oleh pelajar-pelajar saya. Alhamdulillah, okey, ini struktur daun. Okey, ini kita nampak, okey, chloroplast clear sangat, okey. Dia nampak stoma terbuka, okey. Paramecium. Okey, so pelajar boleh nampak secara live ya, paramecium yang yang dihasilkan. Selalunya pelajar-pelajar tengok saja ke internet. Okey, so sekarang mereka sendiri biarkan, mereka sendiri hasilkan paramecium. So mereka terpaksalah menternak paramecium. Okey, ini pun sama juga. Okey, organisma dalam kolam. So mereka nampak benda ni bergerak. So alhamdulillah membantu pelajar untuk minat. Okey, kemudian slide terakhir. Okey, kemudian end sekali adalah kelas online. Okey, saya buat kelas online sebelum PKP lagi. Memang saya ada group, okey, selalunya cikgu kita ada group dengan student, so kita akan bagi soalan-soalan. Okey, dan ini pun ada masa dalam PKP, contohnya latihan-latihan yang diberi, kita tanda, okey, kita check dan ini adalah video, okey, di mana kelas online ini, okey, pelajar tulis sendiri, okey, jawapan dia. Ini ada Mendel. Suara saya lah tu. Okay, so pelajar-pelajar dia tulislah dengan pen, dengan dengan mouse ke. So walaupun tulisan buruk, saya katalah, tapi alhamdulillah mereka faham. Okay. So macam dalam kelas saya dengan pelajar, mostly saya akan macam anggap mereka macam kita punya kawan juga. So tak ada. Okay, seterusnya yang ni latihan-latihan yang saya akan beri kepada para pelajar. Okay, and ends, saya punya slide presentation adalah saya memang menekankan untuk model pembelajaran 5E, iaitu engage, explore, explain, elaborate and also evaluate. Kita applykan benda ni, insya-Allah pelajar-pelajar kita akan mudah faham. Okay, itu saja daripada saya, Cikgu Ayu.
Alright, terima kasih Cikgu Ayu atas perkongsian the best practice. I think very interesting with the movie that you made, and I believe that everybody enjoy. Terima kasih Cikgu Ayu. Okay, so ladies and gentlemen, we would now like to invite Puan Tan Pei Ling, the Secretary of Sept, to say a few words here. So Puan Tan, please.
Okay. Hello everyone, it's me again. So I'm the Honorary Secretary of SMAP, the Association of Science and Maths Education Penang. So I'm here taking a few minutes of you. I know that you have already paying a lot of attention in listening. So thank you so much. And then also thank you all the speakers. It's so nice. I've enjoyed every session. All right. So I'm taking this opportunity to actually promote to you SMAP. So we are actually a body, NGO, I should say, an NGO of teachers and also educators. We all join together to actually contribute our ideas, sharing, and also we are a group of teachers who actually we try to do things and not try to improve the quality of education in Penang. All right, so we do invite you to join us because every year we'll be having our AGM, and then during the AGM we usually have our sharing session from professors and also lecturers, also teachers. So like the one that we are having it today, this is our first time organizing workshop. So we do encourage you to join us, partly so that you can also enjoy knowing the first-hand news. And then every year we will also organize pertandingan literasi sains antara sekolah-sekolah menengah. This is also to encourage the students to getting know better about STEM and all that. And also now we are actually working on Sept, which is another thing, another initiative under us. All right. So can I have a share screen? Okay, I'm sharing to you here. If you're interested to join us, all right, let me see here. Application. Okay, so I'm sharing with you. This is my, okay, can you see this? I'm showing you the Facebook of SMAP. Okay, so there are several channels that you can access to us. The first one is this Facebook. This is one of the channel. Can everyone see it? Can I have some response? Okay or not? Miss Ng, can you see this? Yes,
Yeah,
huh?
we can.
All right. So if you log on to Facebook, please search under SMAP. All right. So you will see this. This is our front page. This is our 51st anniversary that we have just celebrated last 2 years. All right. And you come to this one. This is my pin post where you can click on this link and then you'll be able to join us. So we actually have two types of membership. First one is 50 ringgit for lifetime member, and then also 10 ringgit for ordinary member, which is a yearly renewal. So majority of teachers actually join us as a lifetime member. So you can click on this QR code and then you'll be redirected to this Google form. So kindly fill up and then you can bank into us, and then you can email to us as SMAP for the receipts after you have banked in. So I have put in here the email, our official email. All right, and then on the other hand, you can also come to our website. This is our official website, which is smap.org. So you can join us, and then also often visit this website so that you can up to date for all the activities and all that. All right, so Science Sept is under one of our initiative where we have several volumes of it. All right, and we are now trying our very best to come up with the next new volume of it. All right, so we do hope to see you joining us and be part of us so that we can make science and maths education even better in future. All right, thank you so much from me. All right, pass back to you, Ng. Thank you.
All right, thank you, Kuan Tan. Okay, so audience, do you have any questions for Cikgu Ayu first? I think just now I'm neglected, too excited. All right, so from the floor, any questions for Cikgu Ayu? Okay, so we are going to take for 5 minutes Q&A session for Cikgu Ayu. All right, how to join a member? I think, Kuan Tan, would you like to answer how to join a member for SMAP? Hailing?
Yeah, okay. Here in the, please go to, you can have two channels. If you have Facebook, you can search under Facebook, you search SMAP, ASMEP, and then you will see this logo. Okay, let me share my screen one more time. This one, you will see this logo. Yeah, okay, share. So can you see this logo here? Okay, this is our logo. So make sure that you got the right page. All right. and then you just scroll down a bit, you will see this QR code. Please scan this QR code, or you can go to this bit.ly, okay, bit.ly/smap form, okay, or you scan this QR code, then you'll be able to join us. I will ask the organizer to put this, okay, I'll ask the technical team to put this in our live Facebook, okay, and also the YouTube, so that you can access to it. All right, thank you.
Okay, thank you, Puan Tan. So, dear audience, you have any questions for Puan Tan and also any questions for Cikgu Ayu? Calling once? Calling twice? Oh, great job. Great job to Cikgu Ayu and also great job to Ms. Tan Peling. Thank you. Okay, so any more questions? All right, calling once, calling twice, and calling off. Okay, so in case you have any questions, you may email to our speakers. All right, so the next person that we would like to invite is Associate Professor Dr. Azida, okay, the President of ASMEC, for closing remarks. So Dr. Azida, please.
Okay, Assalamualaikum and good afternoon. Okay, thank you all for being here. Okay, thank you also for all the speakers. We as MAP, okay, would like to thank you all so much for being here, so much for attending this our first webinar, yeah, our first webinar, and it has gone through smoothly, Alhamdulillah, and we were actually proud to have so many attendees, more than 130 teachers who attended the webinar just now. Okay, so kami sangat menghargai kehadiran anda semua from Malaysia, from Indonesia, from Bhutan. Yeah, we have participants from Bhutan. So we didn't expect actually participants from Bhutan, but we had a few coming in. So Alhamdulillah, thank you so much. Thank you, Dr. Chin. Thank you, Miss Lee. Thank you, Cikgu Yasmin. Thank you, Peling and Saves. Thank you, Dr. Firman. Thank you, Cikgu Ayu, and all the committee of ASMEP, okay, for having this awesome webinar. All right, inshallah satu hari nanti, okay, one day we will try to do it again. Okay, what we try to do here is that we try to combine all the teachers. Okay, whatever you do in the classroom, share with others. Maybe if you think it is simple, but that is not as simple for somebody else. Okay, maybe other teachers are struggling nak cari idea, looking for ideas how to teach science, how to teach mathematics, how to combine science, mathematics and technology like Dr. Freeman did just now. It is awesome. You had a website using Flash, and we can see how it works for our students. So thank you so much. So I hope that we are going to see you all again. Please follow our Facebook, okay, ASMAP. Okay, look for ASMAP in Facebook, follow, and we will share our next activity. And then we are going to have another big event in a few weeks' time, which is Bengkel Literasi. That is for students, so you can invite your students to join our Bengkel Literasi. It will be online. They are going to produce video, and we are going to have them in an event whereby we are going to pick up the best videos in science and mathematics, in STEM, all right? And we will have a winner. This is our yearly event. Usually we did it face to face, but now we are going to do it online, and we are going to open the event for everybody. Okay, insyaAllah. Okay, thank you very much for all for being here today. InsyaAllah we will see you in our next event. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Back to
Okay,
you,
thank
Fong.
you. Yeah, thank you to Associate Professor Dr. Azida from USM. All right, so I believe each and every one of us have gained more knowledge and broadened our views from the sharing of Guru Cemerlang in STEM. Once again, thank you for gracing our workshop Bengkel Perkongsian Amalan Terbaik Guru STEM dalam talian tahun 2020 with your presence and participation. So reminder, please fill in the e-survey to receive the e-certificate of participation. So I'm going to share my screen with you. Okay, I'm going to show you the, all right, the QR code. Can you see my screen? Can you all see my screen? Can I have some feedback?
Yes, can see.
Okay.
Yes, can see now.
All right. So this is the buku program Bengkel Perkongsian Amalan Terbaik Guru STEM dalam talian tahun 2020. So participants, you may scan this QR code to find out the presenter abstract. At the same time, you can get the e-survey form or feedback from this link. Okay, so once you fill up this survey form, you will be able to get your certification. Okay, so yeah, that's all. That's the end of the session. Okay, so I think I will stop sharing here. I come back to the here. All right. Okay, so this is the end session, and I hope you enjoy the program. Thank you and have a nice day. Yeah, bye-bye.
Thank you, Fong.
Thank you, Doctor. Thank you, Pei Ling. Thank